Good morning, sir.
Good morning. Good morning. Am I audible?
Sir, I think you're muted.
Am I audible? Hello.
Sir, I think you're muted. Can you unmute yourself?
No, I am unmuted only. Hello.
Good morning, sir.
Ma'am, sir's voice is somehow uh, a bit low. Okay.
Hello.
You are audible,
Hello.
but yes,
Yes,
sir,
yes.
you are audible now.
Yeah. Fine.
Shall we start, sir?
Yes.
A very good morning, everyone. I, Deepti Yalanki, working as Assistant Professor in Department of Civil Engineering at Haldia Institute of Technology, welcome you all for this morning session of 5th day online FDP on recent trends in civil engineering. The speaker of the session is Professor M. Amarnath Reddy, sir, and the topic of the session is innovative and durable bituminous and concrete pavements for high volume roads. Professor M. Amarnath Reddy, sir, is presently working as professor in Civil Engineering Department, IIT Kharagpur. His area of specialization is transportation engineering, and specific interests are structural evaluation of pavements, sustainability in pavement materials, and pavement design. He has 30 years of academic and research experience. Dr. Reddy has published nearly 100 technical papers, international, national journals, and conferences, and he has carried out several sponsored research projects and consultancy projects in pavement engineering. Professor Reddy has was principal investigator for a project network center on highway and airport pavements, sponsored by Indo-US Scientific Forum. Currently, he has co-sponsored research projects from government organizations such as NHAI, National Highway Authority of India, Ministry of Road Transport and Highways, National Rural Infrastructural Development Agencies, Government of India, New Delhi. He contributed to the revision of some of the Indian Road Congress IRC specifications and guidelines. He is a member of two technical committees of IRC, Indian Road Congress. Sir, we welcome you to this session and thank you for accepting our invitation for the online FDP and for devoting your valuable time to this session. Over to you, sir.
Thank you, Dr. Deepti and others. Thank you for inviting me for this, I think, 5-day FDP program uh, being conducted by Haldia Institute of Technology. So, let me start my presentation. Let me share my screen. Just a moment. Is my screen visible?
Yes, sir. Yes, sir.
Fine. So, at the outset, again, once again, I thank uh, DP and others for inviting me for this 5 day FDP program. So, today I'll be speaking about an hour or so, more than an hour or so, maybe 1.5 hours or so, about the some of the developments that IIT Kharagpur has done on both bituminous and concrete payments for high volume roads. So this is not from any literature, something like that. This is the work that we have done, and also uh, it would be what you call will be practiced very soon. Okay. So before that, because though there are some transportation people in this, but seeking the knowing the general composition of the faculty spread across different parts of the country, let me give a very brief introduction to the what are the various activities that are happening in India, especially in the road infrastructure. So as all of you know that the highways, of course, are the very important the transportation network that we have in India. We are much dependent on the land transportation, that is road as well as rail, compared to other modes of transportation, that is air and water. Of course, water is very minimal, but other mode of transportation, that is air transportation, also the importance of that is also being there in the recent times. So in the highways, as all of you know that since more than 20 years, more than 2 decades, so there has been a significant development in the road infrastructure that all of you are able to see that. So that infrastructure in terms of golden quadrilateral, which was started way back in around 2000, year 2000, and then it has got different phases, phase 1 to phase 8, that was completed. Later on, it is like a garland kind of a thing to the country. Then followed by east-west, north-south corridors also is completed. Then there was some like important things have been left out. So thereby, especially ports, where you get a lot of the goods from both for export and import. So port connectivity is also has taken up by Government of India. Then in the latest, what are pending works that are there in the Golden Quadrilateral, East-West port connectivity. So they have measured everything and also started a new program called Bharat Mala, which is the latest. There is a phase 1, which is just completed, and of course this will go ahead with that. I will also just highlight some of the features of Bharat Mala a little bit later. Then comes rural roads. Of course, this is also another a wonderful program that is launched by Government of India. This is also nearly 2 decades, mainly to connect the habitations, that is the villages, having a population more than 250 with a all-weather road. Then also we have developments in airports as well, like construction of new airports, that is called greenfield airports, and some of the airports are being augmented, like improved, maybe runway extended, taxiways improvement. For example, in Kolkata, there is also now brownfield kind of a concept, where the runways are being now extended. New taxiways are recently they're building a new taxiways, like rapid exit taxiways are being built, and like that. So those are called brownfield. So this is also happening in India. So when it comes to Bharat Mala Pariyojana, the salient features of it is it connects It provides new 50 new national corridors. There's a huge investment opportunities and development of nearly 25,000 kilometers of road length, and it connects 550 districts. So, what are the main features of this? Improvement in efficiency of existing road corridors, because when we connected this golden quadrilateral, some of the links have become very congested because, of course, because of various reasons, including the because some of the projects were taken up for nearly 1 decade or more than that. So there is a efficiency problems like congestion, etc. So those links are being now improved. That is what improvement in the efficiency of existing corridors of through development of multimodal logistic parks, elimination of choke points. Choke point means congestion. Then enhance the focus on improving the connectivity in the northeast, and emphasis on use of technology, scientific planning for project preparation, and yeah, delineation of powers to expedite the project delivery, and improvement in the connectivity. Of course, already I told you about northeast. These are some of the the targets that they have picks up in the Bharat Mala: economic corridors, feeder roads, national corridor efficiency improvement. Okay, then border roads also, international connectivity is also taken up in this Bharat Mala. Port connectivity and greenfield expressways are coming up. I think you know that Mumbai to Delhi, okay, greenfield expressway is almost ready. Some parts are ready, almost it is getting ready. So that kind of greenfield expressways are also being planned. And the other important thing, as I said earlier, was the balance National Highway Development Program at NHDP, like Golden Quadrilateral, port connectivity, because it took in different phases. What all pending things were there, those are also were taken up in this program. So you can see that it talks about economic corridors to port connectivity, greenfield expressways, and including the balance works that have been there also been taken up under this program. So I think all of you know that the responsibility of constructing these developing road infrastructure and maintaining the road infrastructure lies with NHAI and of course National Highway Authority of India, and they also have because of some administrative and other reasons easy to expedite the work. They also started another organization called National Highway Infrastructure Development Limited, mainly to take care of the road connectivity in the hilly terrains. And of course, the state national highways, PWDs are also taking up some of the works of national highways. So in all these things, what has been done is last 20 years or so. More earlier we had mostly our national highways were now it is almost 1.5 lakh kilometers. Earlier the number was less, and even the number whatever we had, most of the infrastructure has 2-lane roads. Now it has been now upgraded to 4 lanes, 6 lanes, even 8 lanes also. So in this process, what has happened was it is naturally widening. Means 2 lanes to 4 lane means widening. 4 to 6 also happened. Sometimes some places 6 to 8 also. So all these comes under widening and strengthening. And in addition to construction of new express ways kind of things are some of the national highways also some places. And in this process, it is not only just widening and strengthening, they've also eliminated the poor road geometrics. So those who have got, of course, have studied that road has some geometrics, the alignment now, it has to suit the design speeds. Normally, design speeds are 100 kilometers per hour for national highways, and minimum is 80. So all the geometrics means curves, side distances, vertical curves, horizontal curves, everything has to be designed for 100 kilometers per hour. Then only to say that the journey 100 kilometers speed journey would be safe. So so in these projects, uh, most of the places, I can say the more than 95% of the places, the geometrics were improved. Okay, so that is another significant development that has taken place. And as I said, there was a development of expressways on major traffic corridors, and also the assets were. This is one of the area which is coming up. Preservation of road assets, because we may not be able to go on adding the new highways. Okay, so like in US, yeah, around 1956, that time the interstate highways they have developed in a large scale, and later on it's only the road asset management. So in India also that has started, and this will be a future area, that is payment asset management. So that also we have started, because roads, you cannot, only there is a design life. Even sometimes these structures are going to fail prematurely. So you need to manage wisely. Wisely means you have to do maintain on time, so that later on the assets condition become worse than where you have to invest more. Such kind of things should not be there. And another very, very important task that the government has taken up in the recent time is safer roads. There is a road safety auditing. Huge amount of money is also being spent on how to make our roads safe, because such a vast country. And I was told that last 10 years, the number of accidents or fatal accidents in India are up to 1.5 lakhs. So this many people are being killed every year, and the almost 15 lakh people are killed in the last 10 years or so, which is very, very concern to us. So thereby, how to make roads safer. So those programs are also taking up in under different E's. So we have like engineering, education, enforcement, then emergency assistance, okay, evaluation. So different E's. Now earlier we had three E's, now six E's. Okay, so these things are happening in a large scale. So what are the major problems that India has? So there is a good economic growth in our country for the last 20 years or so, and the impact is on highways. So there is a huge what do you call increase in the traffic volumes, the axle loads, trucks carrying, especially the trucks that carry load also increase. And also, though we have restriction on tire pressures, but people go with higher tire pressures. And other major thing is, which is also great concern to all of us, that there is a fast depletion of natural resources. So because of huge construction, not only in the road infrastructure, but building infrastructure is also happening. So with this, there is a fast depletion in the natural resources. So this also one need to consider, that means how to preserve the natural resources. So everywhere that is called sustainability, what we call it as. So these are some of the issues which we need to taken up. And one of the main challenge or motto of any transportation or any civil engineer, especially when you talk about road infrastructure, is to see that can we build a durable roads. Durable means long lasting. Okay, because the normally we design the uh, flexible payments, like the bituminous payments, for 10 years time. Okay, 10 or 15 years. Concrete roads slightly higher, 20 years. But then we design, but what is happening is they are failing prematurely. Actual life sometimes become 2 to 3 years. Why 2 to 3 years? Sometimes 5 years. Why prematurely? Sometimes is the construction quality. That is one. The second issue is, though quality is executed, what is happening because of the, the increase in the vehicle axles. So we are not able to predict the traffic growth. We design for something, but actual traffic is much more than that. So the design life is being consumed or applied on that particular highways, even within 3 years or 5 years. So that is what happening. Okay. Even village roads are also not lasting for a good number of years. What has been designed. So now, what is the alternative that we have? Whether we have, of course, durable concrete roads, or concrete roads are durable. Can we say that? Yes, the perception of any public is that concrete roads are better than bituminous roads. But of course, that is a thing which cannot be discussed here. But both roads are having definitely a long life. But only thing is, when it comes to quality and all, then the issues comes. So you see that bituminous payments will just has got very less life because of various reasons. So now, thereby, Government of India has taken up construction of some concrete roads recent times. Earlier, we had a good number of concrete roads, but government has not taken up much of the concrete roads in the recent time. But last 5 years, uh, government initiated a good number of concrete roads. So concrete roads, what we have is with the different types of concrete roads. Uh, so see, I use these terms. We payment is a structure. When I call about this is a structure, so I call it as a payment, and when I call it a facility, I call it the road. Okay. So as is a structure, so we have a jointed different types of concrete payments. So the most popular one that what we adopt in India is a jointed plain cement concrete payments. In a short term, we call JPCP, where you can see that the you can see the width of the concrete pavement is equivalent to one lane, single lane width of vehicle in any road infrastructure is 3.5 meters. So 3.5 meters this side, and length is 4.5. So this is the longitudinal direction is 4.5, and the lateral direction it is 3.5. So you can see this is 3.5, this is 4.5. So it is a saw cut, though it appears to be totally discontinuous. It is not a discontinuous. A saw cut is done. A saw cut a width of 8 to 9 mm saw cut width is done. This is called a contraction joint to allow the contraction, expansion, all those things to relieve the stresses. We normally cut this after placing a concrete within 8 to 16 hours. That depends on the climatic conditions over there. And then we normally drop double bars on the longitudinal direction here, and tie bars with the adjoining slabs, so that they keep at same level, and the double bar function is to transfer the load. So this is a very conventional concrete pavement that is being designed. So there's a guideline called IRC 58 2015. This guideline was also is drafted, and revisions were made, and from the contributions that have done from IIT Kharagpur, of course, taking the international experience, the guidelines were there. So the guidelines on IRC 58 related to jointed plain cement concrete pavements. Okay. So this is what it does in the jointed plain cement concrete pavements. So we cut up to 1/3 depth, just see, and you will drop a double bar. Double bar is to transfer the load from one slab to other slab, though there is a aggregate interlocking. Only we cut up to 1/3 depth, and later on it is expected that there will be a fine crack. It may form, may not form. Even if it forms also, it's a fine crack. Still there is a interaction between the two slabs and load get transferred. So in order to ensure that the load is really being transferred or not, we are normally placing a double bar. So you can also construct jointed plain cement concrete without double bars. But the practice in India right now is to use a double bars for this purpose. Okay. So in spite of what you call designing as per IRC 58 2015, there are several failures on concrete pavements. Okay, you can see that there is longitudinal cracking. Mostly the failures in concrete pavement are the cracks. Okay, for various reasons, there is a corner crack, longitudinal transfer. Okay, like number of cracks are there. You can see this is a longitudinal cracking. After 2 years of construction, it has happened. Corner cracking, you can see this is a corner crack after 4 years. This is some transverse cracking. This is a longitudinal wide crack. Okay. You can see that this is also a longitudinal crack, you can imagine. And very difficult for once a concrete slot, because this brittle material, once the concrete exhibits especially this kind of failures, it is very difficult to repair. Okay, so the guideline also it is said that when the depth of the crack is equivalent to 50% of the thickness of the slab, you may have to replace it. You may have to replace, which is very costly affair. But before replacing, we normally, of course, we normally do one investigation why the concrete pavements are failing, etc. That is a you have got IRC SP 82 guideline is there, so you need to figure out the reasons for concrete pavement, and then of course there are some kind of rehabilitation methods before you the slab is being replaced. Okay, some of the photographs you can see. This is one of the longitudinal cracking where there is a settlement of the subgrade. So concretes, no, they cannot take any deflections. Okay, so when the subgrade settles, because this is a new formation, okay, the subgrade is not compacted, okay, when the widening portion, okay, so thereby what happened, the crack has, because subgrade settled, all other layers settled, including there is a crack on the longitudinal crack on the concrete pavement. So this kind of things, slab replacement is very difficult. You have to break, remove, it's a huge task, then again construct a new slab. So concrete pavements advantages are there, but moment kind of failures which are there, very difficult to repair, and also have to spend good amount of money. Okay, so thereby when there is a problem that engineers are now sometimes are hesitant to recommend rigid pavements, concrete pavements, because the cracks which are developed within the 3 to 5 years. So there should be a, that's what the feeling is, we should try to develop, restore the confidence to take up the concrete roads by adapting other kind of concrete pavements. If this is jointed or where things are little easy, I'll show you later on, discuss about that. And as I said that it's not that slab replacement is warranty always. There are rehabilitation methods, when especially when the width of the cracks and the depth of crack is well within the limit. You have got some kind of procedures, especially the one which I'm showing you here called stapling, stitching and stapling. So you can, like, as you can see, this is like a staple. These are like this is the two part. Let's say on either side of the joint, you cut up to the required depth, affected depth, slightly more than that. Then place a staple pin. This is not a staple pin, it's a reinforcement actually. So you place it, and then what you do is you fill up some epoxy and seal it, so that further the crack will not be widened. Okay, this is called stapling. There is also stitching. Stitching means like how you stitch your clothes. You can also stitch the payment again using some reinforcement. So this kind of um, the stitching and stapling are some of the remedial measures that is being done. So, but these are costly affair, because epoxy, all these things are very costly materials, and yeah, you have to invest good amount of money to rehabilitate the concrete pavements which are there. Yeah, this is, you can see, though you'll not be able to see. These are this. Of course, this is a stapling I'm showing. You can see this one, where we place we drill a make some kind of slot, drillers, and place a reinforcement like a stapler, okay, and put epoxy. So this kind of rehabilitation method is being done. Of course, this was of course a photograph where we of course evaluated performance of payments before and after stitching, whether there is an improvement, etc., using a vehicle called falling weight deflectometer. So that means that what we understand till now is in India we are using we are adapting. If we go for concrete payments, it's only JPCP, that is called jointed plain cement concrete payment, where the what do you call the slab dimensions of a concrete payment is 3.5 by 4.5, and there's a guideline called IRC 58 2015 is being adopted, where the analysis means analysis for stresses, both load and temperature stresses are taken combinedly, and single slab analysis and FEM was used to analyze the stresses, and then accordingly cumulative fatigue damage is the principle that was used to arrive at the thickness of the concrete pavement that is required. So if you go through that guideline, you'll be able to understand how to design a concrete pavement, and there is an Excel sheet that is also given in the guideline. Guideline can be downloadable. Okay, you can download the guideline, and you can go through that. So this is what we are using. So usually for a if I want to design or if I want to approximately say that I want to design a national highway where the traffic is very high, uh, maybe for 15 years or so, or 15 or 20 years, the thickness of the concrete pavement concrete layer, that usually we get around 280 or 290, almost like our scale 1 foot, almost like 1 foot, okay, almost like nearly 280 290 mm we get that. So almost like, as I said, no, 12 inches 11 inches of concrete pavement thickness you get if you design that. And of course, when the traffic is less, it may come around 240. That's something on the order of that. Okay, designs, you can go through that. Now, what is there any alternative to these concrete pavements? Again, in the concrete only, but what is other alternative? The other alternative, what we have proposed, is a short slab concrete pavement. So we have named them as SSCP, short slab concrete pavement, and we have constructed nearly 3 kilometers of such road, such pavement structure on one of the busiest, one of the national corridors, which connects Jamshedpur, okay, Baragora to Mohalia, on NH. Earlier NH is called NH 33. Now the new NH is NH 18, and this is a part of NHA sponsored project, which was we started in 2016 and ended in 2022. Okay, so where what we did was we constructed. It's like a regular concrete pavement only, not like concrete how you laid on the concrete, everything same. But only thing is we cut the joints one third at a closer spacing. Like I'll tell you later. Like the slab size are no more 3.5 by 4 point, but they are 1 meter by 1 meter or 1.5 by 1.5 square slabs up to 2 meter by 2 meter, or even it can be rectangular as well. Okay, but not 3.5 by 4.5. So, and what we did was we analyzed. I will share you a little bit later. We adapted same principle, the design, how to design this. So since their slabs are smaller, so we did again FEM analysis where we consider not single slab analysis, but we took 9 slabs. For example, when a load is here and load is, though this is only one third depth, and remember this is cut similar to what we have seen there in the JPCP, but the width of the cutting is only very small, only 3 to 4 mm. There it is 8 to 9 mm. The width of the joint is only 3 to 4 mm, just so that even water also cannot ingress just like that. Okay. So when a load is placed here, load is transferred. Load is being transferred through one slab to other slab. And remember, there is no reinforcement here. Unlike we have seen here in the concrete pavements, we have seen there is a reinforcement here. But we have not dropped any reinforcement. We believe that because of agreed interlocking, the load will be transferred. So thereby, we did not place any what do you call the reinforcement double bars here, but only end of the day work. I'll show you photograph. End of the day's work. Today you are completing work. Tomorrow you are starting another again the concreting. Then there only we have dropped the double bars. Other places no reinforcement. So we analyze. When I place a load here, wheel load. When I place a wheel load, we consider that load is being transferred to other layers, other slabs. Then we consider 9 slabs for analysis. 9 slabs. That is, suppose if a load is here. So let's say load is on this slab. So we consider adjoining slab. This slab, this, and this side also. So 9 slab. So it's a multi slab analysis. Whereas in case of regular concrete pavement, though load is being transferred, because of large size of the panel, they only consider single slab analysis. So here we have considered 9 slabs to analyze this and came out with design. So what is the advantage of these slabs? And advantage of these slabs is you can reduce the concrete layer thickness by 20%. So what we did was, this project, on either side of this, we have a regular concrete pavement. Conventional concrete is there. So that the thickness of that concrete pavement is 270 mm. But what we constructed was, it's only, just see, 180 to 220 mm. That's all. So that means 180 means, imagine 90 mm is the reduction thickness. Even if it's 220, it is 270 mm, because we want to experiment it. What we did was, we have considered 3 slab sizes. I have got slides. Yeah, like this. You can see the slab sizes are 1 meter by 1 meter, or 1.5, or that is 2 meter by 2 meter. So the thickness for this, we consider for 1 meter by 1 meter, 180 mm of concrete layer, for 1.5 1 point, 200 mm, and 2 by 2 meter, we have considered 220 mm. And you can see this is the like regular concrete after it is being placed. We use the joint cutters, okay, to cut the, we call the 1/3 depth like this. I'll explain the concept why there should be reduction in thickness. So it is only 3 to 5 mm. We are cutting the width of the crack with this cutter, and within 8 to 16 of course that depends on the climatic conditions. So timely joint. This is what the concept is. When the slabs are large, that is a conventional one, JPCP. When the load is applied, the load is distributed on a wider area. But here, because slab size, this is a concrete pavement. How the load is transferred. The load is transferred by a slab action. As the slab size are bigger, you'll see that load is transferred through a wider area. But in case of short slab, what happens? So thereby, since load is being transferred a wide area, so bendings, that is flexural stresses, are the critical one here. But when I make the slab size less, for example, imagine that the slab size is 30 centimeter by 30 centimeter, like equivalent to your the thickness, the width of the tire of any truck. So tire of a truck, when I take impression, approximately I get 30 centimeter. So imagine that you have built only 30 centimeter by 30 centimeter slab. Then what happens? The loads are only compression. It is not flexure which will be mobilized. It is only compression. That means if I reduce the slab from 3.5 by 4.2, just imagine 3.5 meters to 4.5 meters to that of a 0.3 meters by 0.3. A square slab of 0.3 by 0.3 which just accommodates a tire of a truck. Then it is a totally compressive. Okay. It's a compression comes into picture. So you have to design for a compressive strength of a concrete. That's all. Not flexural anymore. But if the width of the slab is more than 0.3 meters, for example, in this case, 1 meter by 1 meter, sometimes 1.5 meters. So what happened is the combination of flexure as well as the compression. Concrete is very good in compression. So the flexural stresses are going to reduce if we take 1 meter, 1 meter, 1.5 or 2 meter by 2 meter. So because it's a combination of both flexure and compression comes into picture. But when it is a case of large slabs, it is only flexural stresses will be important for design. So here, as the flexural stresses are less, and similarly the curling stresses, temperature stress due to the differential, because of the temperature differential, the curling stresses are directly proportional to the length of the slab. As the length of the slab is less here, okay, less here, again curling stresses are going to be less. So overall, in the net effect, both flexural as well as the curling stresses are, which are the main stresses that need to be considered in the design of concrete pavement, would be less in short slab, or what we written is short panel also, one and the same, short slab concrete pavements. So since the stresses are going to be less, it demands less thickness. This is a concept that we have used, and then we have gone ahead with the construction of such things. Okay. So initially what we did was, we did only single slab analysis to get the approximate thicknesses. These are thicknesses. And as the compression also comes into picture, what we did was, those who are familiar with the road construction, the bottommost layer is a foundation layer we call subbase, and then we have a subbase course. So normally we use GSP, granular subbase, but here to make strong foundation, because of the compression also get mobilized here because of short slabs, we are using some cement here. So it's a strong foundation. So not just granular subbase, but we are adding we have recommended 3% of cement so that this becomes a bound layer. On that, there is a conventional DLC that is called dry layer concrete, and then we have placed a concrete slab here. So the difference between regular concrete pavement and this concrete pavement, regular concrete pavement, so you will not have cement treated. It is just subbase with GSB, granular subbase. But since, as I said, there are compressive compression of the, the load, the combination of flexural and compression. So we are making strong foundation. Thereby, we are recommended cement treated subbase, where 7% is only just like conventional GSB material you take, but you add 3% cement and DLC. Then, as I said, the thickness of that we have adapted we from single slab analysis, we got around 180 mm for 1 meter by 1 meter, or 1.5, 1.2 meter. I'm sorry, 200 mm. For 2 meter by 2 meter, we got around 220 mm thickness of concrete pavement. These we have constructed. This is what this photograph which I showed you now. Yeah, on this we have different combinations. Okay, we have constructed, and as I said, that the bottom layers are like this. What we did was also this project on NH33 or NH18 new number. So this existing bituminous pavement was there. So the proposal was to remove entire bituminous pavement and then start constructing from the subgrade onwards, or subgrade onwards. Yes. What we said was, please leave 1.5 kilometers of bituminous pavement as it is. What we said was, we make that existing bituminous surface free from any distresses, failures, by milling out the material and use the same structure. That is, whatever layers that are there, the top layer is bituminous which is milled out and make surface proper. On this, we place a concrete pavement. That means two types of concrete pavements where the bases are different. So one is this base. The other one is this entire thing is existing. This entire structure is existing bituminous pavement. That is, this is bituminous pavement, existing one. And then on that we have put a concrete slab. We want to see that whether this existing bituminous pavement itself can act as a foundation for a concrete pavement. So that also we have considered. So in the analysis, normally those who know about concrete pavement design, we give K as the input. That is called modulus of subgrade reaction, goes as the input for the pavement design. So if it is a DLC, cement treated, subbase and subgrade, we have one type of K value. And if it is a existing bituminous pavement, you will have a different kind of K value. So that is the only difference in the analysis. So we, of course, interface conditions also we changed it, and then we did an analysis and came out with this. So this is a analysis that we did it, and this is a construction. You can see, yeah, you can see that CTB around 2.5%, and DLC M10 grade of concrete, and this is a paving quality concrete M40 grade, and 180 mm because the thickness is the slab size is 1 meter by 1 meter. So this is the section details. Later on, after we constructed, we did a structural evaluation using a falling weight diffractometer. The purpose of this is to find out how the load transfer, because there is a joint. You can see there is a joint here, whether load is being transferred, shared by the other slabs. If it is so, how much percentage of load is being transferred. So we did this because this is one of the concern, because there is no reinforcement, there is no double bars. So what we did was, we did this what do you call the falling weight deflectometer, that we call structural evaluation on these test section that we have constructed, and then the details were of course recorded, because this is, we want to ensure that whether the load sharing, whether the drop in load sharing to the adjoining slabs is happening, or still it is within limits. So we found that the joint efficiency after 3 years of construction is even still, it's more than 75%. So normally we require 50% for design, but it is still having a higher joint efficiency. So thereby, whatever assumption that we consider, that where load will be transferred from one slab to other slab by agreed interlocking, that was valid from these experimental investigations, field investigations. So this is a construction process of yeah, you can see that is a GS, sorry, cement treated sub base is being there. That is called cement treated with wet mix macadam. That the gradation, then the DLC and DBM, all these things. So you can see after construction, yeah, this is the loads that are being transferred. Yeah, this is you can see from here we have started our test section. You can see the different. So if somebody who are of course close by, we have placed a board also there. Experimental test section of short panel concrete pavements. So the inspiration for this is on a Bangalore, no? Near Bangalore, there is a road called Nice Road on which connects the Mysore Road. So they have also done this job on existing bituminous pavement, or they call existing DBM, means dense bituminous macadam or bituminous concrete. This is a bituminous layer. So they have placed a short slab concrete pavements similar to what we have done. And of course, this work was done much before us, around 2000, I think 13 or so. So this was a successful story. And even till today, after even 10 years of life, very few panels are supposed to be removed, replaced. And panel replacement is very easy. Even something, just see, if this panel is damaged because of excessive, let's say, like cracking and all, you can easily replace rather than replacing 3.5 by 4.5. So slab replacement is very easy, and no double bars. Construction cost is going to reduce, and especially this kind of existing bituminous pavement, you are not damaging any bituminous pavement. You are using the existing bituminous pavement as it is, and on that you are constructing a bituminous concrete layer. There also we did the structural analysis, like structural evaluation by FWD. Of course, these are actually are brought from concept of white topping that is being done in urban areas. Like if you go to Bangalore, Hyderabad, Nagpur, Pune, so on urban roads, I'll show the photographs. On urban roads, you can see, on urban roads where you don't have commercial traffic, existing bituminous pavements are being overlaid with white topping. That is called concrete roads. Same concept. But only thing is, these are urban roads where there is no commercial traffic, very rare. Loads are very less, so they may survive. But we have extended same concept to a national highways. Same concept to national highways, and where the design should be different, because you have to take a cumulative fabric damage into consideration, similar to what is there in IRC 58 2015, the design guidelines for jointed plain cement concrete pavement. Same concept, but for short panels. I said 9-panel multi-slab analysis was done again in FEM. All these things are done. So that means, so with this result, what is happening is we have submitted this to Indian Road Congress, that is IRC, for considering as a new guideline. And for information, I would like to inform that these guidelines have been accepted, and very soon, maybe within a 6 months or so, even less than that, these guidelines are going to come up. The guidelines are like this. It's IRC guideline on design of short slab concrete pavement for highways and expressways. So this was submitted by the, and this kind of guidelines are not available. We have searched in the literature also. Such guidelines are not available for even for international forum, except some places in Chile and other places they have done a small amount of experimental work on this, but no other place. Of course, we did not come across any literature on this short slab concrete payments. So the guidelines will be like this. As I said, that this is a outcome of a sponsored research project sponsored by Government of India, that is National Highway Authority of India. And yeah, broad objective is to design a short slab concrete for high volume roads. So what we did in this is, as I said, that different slab sizes are considered: 1 meter by 1 meter, 1.5, 1.5, or 1.25 also we have given analysis, and 1.75, 2 meter by 2 meter. That means user can choose any of these slab sizes, and can follow the design procedure that is given. And what we observed was the thickness is around, of course, I cannot say that for all the layers, but usually if I take, say, again, say 1.5 1 meter, when I compare with a conventional concrete pavement, the thickness reduction is around, overall you can say that 15 to 20% is a saving, okay, including the, what do you call, the thickness reduction, and what do you call, the saving in double bars, and the extra expenditure that you are going to incur for making a cement treated the sub base. So that means all these things, when I consider, the saving would be around 1.15%, 20%. And in case of the existing bituminous pavement, that means you don't remove the existing bituminous pavement just to construct concrete pavement. You keep it as it is, do some minimal like milling and this thing, and use the same surface. Use the same surface. That means use the same bituminous pavement for construction of these things. So all these things are considered in the design. Or even somebody can construct a bituminous pavement, but only at the top, new bituminous pavement, let us say, new bituminous pavement. And then on top, they construct a concrete pavement, concrete layer. So that is also part. That means either existing bituminous pavement can be used, or you can construct a bituminous pavement, and then on that you put a concrete pavement. And or the other option that I have told you was the CT, GSB, then DLC, and short slab. So all these three combinations are possible. We have given the design for such things. So that's what the main thing. The flexibilization for more than 3 years, then analytical work that for design is a combination of all these things has resulted in the design of guideline for short slab concrete pavements. So this is what the analysis. Earlier we told single slab analysis, but this is like a multi-slab analysis, okay, where transverse cracking, load position that is considered for transverse cracking like this. Similarly, for load position that is considered, this is for daytime temperature differential, that is called positive temperature differential. This is for negative temperature differential, that is night time, where the slab is like this kind of a shape. When the load is placed here, so how the stresses are going to be developed. Okay, this analysis has been done, and at the end we have also given similar to IRC 58 2015, where we gave a what you call a Excel sheet. We have a lot of regression equations here, and for user point of view, uh, we can use either regression equations to compute the stresses and then do the analysis and do the design calculations, or you can simply use the what do you call the Excel sheet that we have given to design the short slab cement concrete pavements. That is about the one of the new concrete pavement which is going to join the family of concrete pavement. So we have the concrete pavements, different concrete pavements like JPCP is one. There is also one more concrete pavement which we are not using, is called continuously reinforced concrete pavement, that is CRCP. And we have RCCP, that is reinforced concrete pavement, is also there. But these two are not, we are not using, because if you don't want any joints, then you should go for this type of pavement that is called reinforced, continuously reinforced cement concrete pavements. But the one which I've added is called SSCP, that is called short slab cement concrete pavement. So that's about that work we have done. And also, just for information, I'll also say that this is also another type of payment that India wants, because what is happening in concrete roads, okay, what is happening is there's a huge noise compared to bituminous pavement. There's a huge noise. How to address this noise? There are different ways. What people say that on concrete pavement, you put 20 of bituminous pavement, again some bituminous layer, only for addressing the what do you call the noise, and of course other benefits. So you can do that. But again, there is also another material you have to close. But is there any other way? In European countries and German, so what they use is they constructed 2 layers of concrete pavement. So 2 layers of concrete. The top layer for 2 to 3 inches only. So they put a kind of aggregates called exposed aggregate concrete surface, EACS. Okay, where aggregate sizes are exposed aggregates. You can see this is a bigger size aggregates. Okay, and this is only for reducing the noise. That means top layer is only function layer, but bottom you have a structural layer, regular concrete, where the gradation will be different. So these are two layers of concrete. The top layer is only 2 to 3 inches, is only for functional purpose, where the that will address the noise, that will reduce the noise to great extent, but that will not serve the full function of the structural requirements of a concrete pavements. So thereby the bottom layer should be structural layer. So these 2 layers will address the exposed, this is called as exposed concrete aggregate surface, for addressing the, anyway we have not done any work on this. For information, I'm just telling you that this is also another type of concrete pavement that people can think of. This is about the concrete pavement, that work that we have done. In a similar fashion, we also taken up, of course, before I conclude that, the other advantages is sustainability, because we are reducing nearly thickness to an extent of anything from not less than 40 to 50 whatever size that you adapt. Okay, 30 to 50 thickness is being reduced, and thereby you can reduce the consumption of what you call the aggregates and cement, other things. So it is also add to the sustainability, and in addition to other advantages that I have already listed. Similar to that, we also done some work on bituminous payments as well. As all of you know that most of our payments, especially on high volume roads, are flexible payment, that is bituminous payments, where load transfer is grain to grain, not by slab action. So we have both unpaved and paved roads in India, even in rural roads also. Most of the payments that we have are bituminous payments. Now, Now, bituminous payments are being designed by using a guideline called IRC 37 2018. This is the design guideline for design of flexible payments. Flexible payments. So if you see the flexible payments, you have a again subgrade, that is a soil. Then we have just granular subbase, or sometimes we can also use cement. It is called cement treated granular subbase. Then above that, we can have a conventional wet mix macadam, but also you can have wrap. That means if if you have milled out some bituminous layer which is distressed, okay, so that material you can reuse it. That is called wrap. That is called recycle the asphalt payments. That is called wrap material. Wrap material nothing but the used like from existing bituminous payment. If it distressed, instead of throwing away material, you just mill it and stock it and use it. So that is called recycling, which is one of the requirement for India, because you cannot just throw away material just like that. So you can construct a lower base with using that wrap material, or you can also go for cement treated bases. Cement treated sub bases you can think of. That means same thing, no? Instead of just WMM, you add cement, some amount of cement to this, so that layer becomes cement treated. That is called bound layers, which are having even higher life. That means bottom layers are becoming very strong. Then on that, what we do is we put a 2 layers of bituminous materials. So altogether you have 5 layers. If you cut and open a bituminous pavement, you will see 5 layers. Bottom 3 layers are made with non-bituminous, either cement, without cement. Of course, bottommost layer is a soil. Then above that, it is just aggregates without cement or aggregates with cement. When you put with cement, it becomes a bound layer. Without cement, unbound layer. But remember, there is no bituminous material over there. But on the top, you have a 2 layers of bituminous layers. But important thing is DBM, dense bituminous macadam, which is a very important layer, where the thickness of this layer is anything from 120 or 110, let's say 100, 110 to it goes up to 160 mm, depending on the design requirements, 160, 170 mm. So almost like yeah, this much thickness, mm, not centimeters. And top layer, of course, we call wearing course. It is only 40 to 50 mm. It is a 40, 50 even less than also can be there, 30 mm also. So 30 to 60 is the top layer, and bottom layer, which is a bituminous layer, popularly used mix is dense bituminous macadam, and thickness will be around 110 to 160. Now, whether we can reduce this thickness without compromising any quality, without compromising any performance, can we do that? Okay. So that we have considered one option. And what is happening is, in spite of again doing the design as per IRC 2018, design guidelines for design of flexible payments, failures are seen like rutting. Of course, I'm not exaggerating. In some of these stretches, you'll see a severe rutting, permanent deformation, and severe cracking is also happening. All these things are failures. Still, we have not reached a place where the failures are minimal. Okay, because we are struggling to identify the bitumen, better aggregate combination, okay, better construction practices. We are learning, improving, but still we have to reach to a place where we are very confident about materials, we are very confident about design aspects, etc. Okay. Now, very important thing, what we have targeted was this: can we reduce this thickness? Is there any material bituminous material where I can use in place of regular DBM, which is being constructed with VG40 or VG30 grade of bitumen. Can I do that? Okay. Then answer was yes. If I do that, what happened? There is a reduction thickness. Once there is a reduction thickness, cost saving will be there. Or for same thickness, I can increase the long life. Instead of resurfacing at end of fifth year, I can postpone it by another 2 years. So thereby, I am also contributing towards the sustainability because you are saving the material, okay, without increasing cost. Remember, without increasing that is very important. The cost should not be increased. So what we did was, for we thought that let us just target on reduction thickness of the concrete slab and also improve the performance. So for that, the recent times, okay, the top layer, what people have done in this layer, there's no work that has been done for this. For top layer, earlier we used to use only bituminous concrete as the top layer. Bituminous concrete. In the recent times, they've also introduced a French popular mix called stone matrix asphalt. They've also introduced another called gap graded rubberized bituminous materials. So all these things now, for the people who doesn't have much, of course, exposure on this, it's nothing but aggregates and bitumen only. But amount of bitumen, the gradation will be different. Since the gradation is different, amount of binder will be different. Sometimes type of binder also will be different. That's all. Everything looks black and black only, but only thing is there's a change in the gradation, and thereby the amount of binder required will be different. So we have been trying the recent times, last 2-3 years. Earlier we only had bituminous concrete. On any national highway you go, bituminous concrete is the only wearing course that we had. But recent times we are also adapting. As I said, the German popularly used a mix called stone matrix asphalt, SMA, GGRB and all. To see that the quality they are functioning, improving the overall quality of the performance or overall performance of the payment. So that is what has been explained here. This is also one of the layer which is popular in West Bengal, where the place where I stay. It's called stone matrix asphalt. Mastic asphalt, which is done manually, which is like almost like a waterproof material. It doesn't allow impermeable. It doesn't allow water to percolate. And the stones which are plugged here are to improve the skid resistance because this is a voidless mix. Only fine aggregates and hard bitumen are used, and it doesn't require any roller to compact this. They just flow, and then you are plugging the aggregates. So you will see that these kind of roads are very popular in urban areas of in West Bengal. Mostly you see Kolkata and other places. Now they are extending in some of the national highways also. Okay. Anyway, this is one layer which is also recommended in the IRC guideline. Right, so the mastic asphalt. This is also suggested in addition to SMA and GGRP. But what about bottom layer? This is also another layer which they have also promoted in the recent times as a wearing course. Top layer. I'll just go back to this slide again. Yeah. So BC, SMA, GGRB, and one is cement grouted bituminous mix, CGBM, and MA, mastic asphalt. So you can add all two more like here. So BC, which is a conventional as it is, SMA, GGRB, then one more layer called mastic asphalt, which I told you, and there is also cement grouted bituminous mixes. This is a single size bituminous material. You will see single size bituminous mix, and then you pour a cement mortar. So voids which are there in the single size bituminous mix are going to fill up with the cement. So it's a material like a composite material, where you have a interaction between cement and concrete, whose chemistry to be understood in long-term performance. But these are working very fine. These are working even satisfactory. But only thing is, they are like these have been tried in a few places in India, not on express or on highways. But of course, maybe some parts we have done, but not popularly used. But this is also another promising material for bearing course. Of course, we have done some work on that, but not in the laboratory only, which I will not be discussing now. But what is the important thing which I was telling about the this layer? How to go for different layer here, where I reduce the thickness or I improve the performance at the same time. So for that, we have proposed a new mix. Of course, this mix is elsewhere existing. That name that was assigned to that mix was high modulus asphalt mixes. HIMA, HIMA, HIMA mixes. We in India, we have renamed them as high performance bituminous mixes, and they are known as in a short form called hyper mixes. Hyper bituminous mixes. What are these? Where they have started? They have started in the European country, that is in France, early 1990s. So they named it as Enrobes A Modular Eleve. That is a French word. EME. What is this EME? Which is they call it as high modulus asphalt mix. The mix characteristics are like this. Very important. We want to tell in a short form. The bitumen is very hard. Normally, we use here hard bitumen in India is VG40, viscosity grade 40. 40 means it is a 4000 poise at 60 degrees centigrade. That is the viscosity. In a short form, we call it a 40, VG40. But this binder, where the penetration value, if I do a simple penetration test in the laboratory, I get a penetration of 35 to 45. But this bitumen, which is required for high performance, is a stiff bitumen, stiffer than VG40. If I put it in VG term, it will be VG70 or VG80, where viscosity will be at 60 degrees centigrade will be around 8000 poise at 60 degrees centigrade. And if you see the corresponding penetration, it will be 10 to 25, very hard. So that is one requirement. The other requirement is binder is slightly higher. Normally, the binder that we use in your DBM, go back to DBM again, DBM, here is a 4.5. But here you have to use slightly higher binder, maybe 5% binder, 0.5% extra. Okay, that is another requirement. I'll tell you why all these things we are using. So when I add more bitumen than what is being done, my air voids get reduced. Air voids in the bituminous mix. Normally we design the bituminous mix for 4% air voids. Air voids in the mix. If I compact the bituminous mix, prepare a sample, the lab, normally I design for conventional payments, I design for 4% air voids. That means I get the bitumen etc. for 4%. But here 3%. Since I am using, I'm reducing the void by 1%, it accommodates more bitumen. Whatever I told you, the 0.5%. So the concept is stiff bitumen, slightly more bitumen, thereby you get a low air voids. With that, what is happening? That mix will have high structural properties like the resonant modulus value, we call it as modulus value, which is equivalent to elastic modulus, will be around very high value. For a normal mixes, it will be around 3000 megapascals. When I test it as per ASTM D4123, test procedure at 35 degrees centigrade, I get a modulus value of 3000 for a normal bituminous mix. But here, the modulus I am going to get will be around 4000. That means 1000 increasing the resonant modulus. So if I increase the resonant modulus, what happens? The material becomes brittle. If I increase 6000, 7000, I can do that. But material becomes brittle. Brittle means it fails in fatting. Though it is very resistance for permanent deformation, but it fails in fatting. I don't want to fail my mix in the fatting, repeated loads. So thereby I restrict the modulus to be only at 4000 compared to conventional mix of 3000. Then since I have added more bitumen, it gives elastic. That means it can take more because of higher binder content. It fails. Material fails after subjected to higher repetition of loads than if you would have designed for 4% air voids, less bitumen. This fails at lower number of wheel repetitions. So it's all adjustment of the balancing the mix design. That means mix design means amount of binder, type of binder. Okay. So thereby overall what happens, because my modulus value is high, that's why they gave a high modulus as for mixes. But why we don't call high modulus? But it's not only modulus, but there is a good resistance for rutting, that is called permanent deformation and cracking. So thereby, since the performance is better, we named it the high performance bituminous mixes. So these are the either high modulus or hyper mixes, both are the same. So what is the, in a nutshell, if I want to tell, you require a hard bitumen. Harder in the sense around 10 to 25 penetration value. I have to use slightly higher binder, more binder. This more binder is possible when I have low air voids around 3% rather than 4%. So if I have this kind of bitumen, harder bitumen, higher bitumen because of the low air void contents, I'll have higher fatigue resistance. I'll have better rutting resistance. And my material will also have higher modulus. Since I have higher modulus, you know the design principle, IRC 37 2018, I can reduce my thickness. So what happens? Yes, this is what is going to happen. So it is a 40% from literature I took. It may not be 40% overall because I am adding the more bitumen I am adding. So thereby overall it comes somewhere at 20 to 25% reduction thickness. That means rather than 100 mm of dBm, I can complete this work with 75 mm. Rather than 150, I go with 110 mm. So there is a reduction in thickness of nearly 20%, 20 to 25%. So this is also another advantage. So if I use a bitumen which is stiffer than VG40 and designed for low air void content with higher binder content, what happens? I have a reduction in thickness, but also because of stiff material and more binder, I have improved rutting resistance for permanent deformation, rutting for resistance for the wheel load application, that is called fatting. This is the advantage of HIMA mixes. So what we did was we searched any refinery is producing this kind of bitumen. No, because in all the refineries produce only VG40, VG30, VG10, that's all. But accidentally what we found was when most of the refineries adopt airborne process for production of bitumen, where when the process of producing the different petroleum products, the last thick product that they get it is bitumen, but they do some kind of adjustments to make it as required viscosities. So most of the refineries in the country, the thick mass that they get will have very low viscosity, like very high, low viscosity, but To make the viscosity higher, what they do, they pass the air. They call air blown bitumen. They pass the air and they make the bitumen stiffer. So, but if you want to get this kind of bitumen called BG80, they have to pass more air. But when I pass more air, bitumen gets aged, and the aged bitumen will have less fatigue. So thereby, in India, most of the refineries which produces BG40, if I ask them, let's say hypothetically, I ask them to produce BG80, they may produce, but by subjecting the same bitumen to for higher duration of air blowing, and there the material gets aged, and that bitumen, though I get a penetration of 10 to 25, but that may have inferior fatigue strength. But luckily, there are 3 refineries in the country which have got 3 to 4 companies which have got other method of producing the bitumen called PDA process. That is called propane deasphalting process. Luckily, Haldia refinery is one of such refinery where when they produce a bitumen, in the process of producing the bitumen, which is the last product, they get a thick mass. But here it's a reverse. Viscosity is very high, not low. Viscosity is high. High in the sense it is almost like 1500, 15,000, 10,000 poise at, I'm just telling, at 60 degrees centigrade. But whereas the other bitumen, the other refineries where the air blown is then, the viscosity is maybe 500, 600, that kind of thing, where they have to make it stiffer by subjecting it to air. But here, since the viscosity is high, what they do, they add some solvents. Add solvents to reduce the viscosity. What they do, suppose if 15,000 is there, they add some solvents and make it as 4,000 poise, 3,000 poise, 1,000 poise, like that. It's a reverse. So, but for this kind of bitumen, we got this bitumen, and when we tested this, these are the properties that we had. So you can see the penetration value is low, softening point is high, and ductility is high. But only thing is viscosity is also very high, 10,000 or 15,000. That is the kind of range we got. We thought let us try this and use it as a high modulus asphalt binder. Alternatively, sorry for that. So with this binder, what we did was we constructed a test section again in the state of Odisha on NH 18. That is Jarkop Karia to Baripada Balasur. 1.5 kilometers road length was constructed. Let's say this is the construction. And remember, this is a base layer, not wearing course. That is not a top surface. So this was a test section that we have constructed. We did a lot of experiments in the laboratory. Okay. This is a construction of the new layer. Bottom layers are same, but only top layer you can see. This is the top layer we have constructed. Okay. Now, what we did was, okay, refined bitumen may not be available to all because this is an experimental kind of thing. We requested Haldia to give this. Just in the process of just adding the volatile materials to make it as VG30, VG40, VG10, we tap that bitumen and we test it. But that may not be available, and where the viscosity is very high. So alternatively, what we did was, we took VG40 bitumen. Please listen carefully. We took VG40 bitumen. We add polymers. We add polymers in such a way that these polymers, either two polymers or single polymer, we tried both, and see that the penetration value from 35 to 40, earlier it was 35 to 45, reduced to 25 to 10, sorry, 15 to 25. That means we make it stiff. and also make sure that the elastic properties, that is called this softening point, will be more than 60. We tried this, we were successful in that. That means modifying the existing bitumen to make stiff bitumen using the either VG30 or VG40, which you get from refinery. We added some polymers to it, make it a stiff binder, and we tested. And that also we have used to construct the test section with a less thickness. Okay. Then what we found was things were working fine again. Of course, I'm not showing all the details. We have taken a lot of course like this. We're taking course. My photograph. Yeah, you can see course we have taken. We have tested how this material is aging, and with aging, how the properties are changing. All these experimental studies were done. And as I said, we have also constructed 2 test sections. Both are in Odisha state and 2 different national highways. I am showing one national highway here. There is also another national highway on which we have constructed this. Again, we did the FWD, structural evaluation, collecting cores, bring them to laboratory, study the effect of aging, how the material behavior is changing. All these things we have done. And again, with the successful story of this, where I can reduce the thickness by 20% or so, especially the DBM, that is base course layer, what we did was we proposed a guidelines. They called draft guidelines, which was approved recently, like last week only, last before week, they were approved. They are called IRC guidelines for, of course, this is not high modulus. Sorry, we have changed that. Sorry, it's high performance bituminous mixes. So sorry. So this is called high performance. So high performance. So we named it as hyper bituminous mixes. That's just for high volume roads. So this is a guideline which is also approved. And again, this is a work done at IIT Kharagpur by 2 PhD students, where it involves laboratory as well as field kind of things. This will be the content of the guidelines. What is high modulus mixes? Of course, we have changed hyper. Sorry to put in here. These are hyper mixes. Wherever there is HIMA, is to the hyper. Which both are same. Scope of the guidelines, construction, etc. So these are the binders. Remember, just see that the binders. What we have. This is a binder that we have used in France. As I said, no. Later on, it was adapted by Australia and South Africa. So these are, you see, these are binders. See, very stiff bitumen, high softening point, and the viscosity is also very high. Okay, all these properties. So based on this and based on the work we have done, we have proposed binders for India. Please see this. So the penetration should be 15 to 25, softening point, dynamic viscosity, mass change. This one. This part, if you get from refinery, if somebody gets a bitumen, they should test it for these properties. And if it is a stiff binder, hard binder, being produced by process called using modifiers, I told you, no, is a singular, more than one binder, polymer is added to the VG30 or VG40. So for that, addition tests are to be done because there are polymers, no. So you have to have other tests called G star sin delta, which are normally you should have an equipment called dynamic shear rheometer, and these are the other properties which we have got it from the extensive laboratory studies that we have done. So for hyper mixes or HIMA mixes, one and the same, the binders that we have proposed are like this. This is okay about binder. So this kind of binder has to be prepare a mix bitumen plus aggregates. So we name them as hyper mixes, high performance bituminous mixes. So for that mixes also should have some performance characteristics, like it should have a workability, stiffness, rutting, fatigue, moisture damage. For the first time in India, for mixes, we are bringing the performance characteristics into picture. Earlier, we used to do simple Marshall mix design. That is stability, flow, uh, voids in mineral aggregate, VMA, VFB, and finally with 4% air voids, we fix we get the amount of bitumen required for the selected graded aggregates. But that may not give you the performance. So worldwide, they have included performance tests for mixes. So first time we have introduced the performances for mixes as well. So that means if somebody wants to use this kind of mixes, they should have this facility to test it. But since the logic is, since we are going to save 20% of the material and the construction cost is huge, runs into several hundreds of crores of rupees. So purchasing these equipments, which may cost you around maybe a crore or more than that, 1.5 crores. So that is worthwhile to invest, where the overall the amount of the project would be huge. So these are the specifications which we have included in the guideline, which is going to come up, where we have given the specifications for binders, specification mixes, and we termed it as a high performance bituminous mixes for national highways and expressways. So both the projects what we have, where the guidelines are coming up, are addressing the cost cutting, saving in the cost of construction. So all these are done again with the help of students' involvement and sponsored by the National Highway Authority of India. So these are the two durable and bituminous mixes and concrete bituminous layer and concrete layer, which have been introduced, are going to be introduced very soon in the Indian highways. So I wanted to present before you. The last one is what the concern, as I was telling now, when a new road is to be constructed, when you want to change from bituminous to concrete, this is what happening. They are just throwing out the material on the side of the road and nobody is going to use. So rather than throwing it away, let us keep the bituminous pavement as it is. Only do little modification for surface, only by milling, make the surface error free, free from any cracks. That you can do with no time, with the millers that are available, milling materials. Then use the same layer for placing another concrete layer over that, especially the short slab concrete pavements. This is by milling, you can do like this and do that. Okay, another, of course, this is also another work that we have done. Maybe if I have time, I will just tell you. There is also a bitumen called foam bitumen, which is a South African concept, where I produce a cold mix. Normally, all the bituminous mixes are hot. So to address the environmental issues, cold mix are always better. So the concept here is, when the bitumen is hot bitumen is subjected to cold water injection, cold water in a chamber, so you get a foam. That means the volume of the bitumen, which is only 4.5% compared to your of aggregates, the volume increases by 20 to 30 times. So during that time, you mix this with aggregates, and then within maybe 10, 20, 25 seconds, the foam gets dissipated or disappears and finally comes to the original shape. During that time, you apply this foam to the what you call to the aggregates, and the mix that you get is called foam bituminous mix. And the properties of this are they are not as strong as the hard hot mix asphalts, but nevertheless they have got good amount of structural properties. And the main advantage is when you are doing this milling, and you are doing this kind of milling job. So one of the treatment that you can use the cold mixes, this kind of foam bitumen, where your mixes are finally the mix now it comes out from the mixing plant is cold. So cold mix you can apply and no environmental issues, no carbon emission, okay, carbon dioxide emission, all these things are you can minimize. So that is also add to sustainability. So we have also done some work long back in Kolkata, and recently, of course, we have also one of my colleague has produced a PhD on this foam bitumen characteristics. So this is also, of course, not much popular in India, but here and there they are using. Okay, this is a work we have done with Kolkata long back, where the existing bituminous pavement was rehabilitated. That is distressed bituminous pavement was rehabilitated with using a foam bitumen. Similarly, the last one which I wanted to tell is IIT Kharagpur, late Professor B.B. Pandey, has propagated another innovative technology for low volume roads. It is called self-fill concrete pavements, where the plastic shells are made and a drying concrete of M20 grade of concrete is M30 grade of concrete is being placed um, and compacted using with either with a rollers or with a compactors, brake compactors, if the length of the stretch is very less. And this serves the purpose of both these properties of this because concrete when you're placing in a thin plastic shells, it leaves some kind of cracks, finer cracks, and then the material is not purely acts as a concrete. So that means the it's a combination of behavior. It's a bituminous and concrete, and where the life of these payments are very high. I mean, compared to the conventional and thickness also you can reduce, and especially these are meant for low volume roads. So technology has also been transferred to National Rural Infrastructure Development, that is called NRRDA, NRIDA, which are taking up the Pradhan Mantri Gram Sadak Yojana roads, the PMJSY roads, and a lot of states are also implementing this kind of uh, self-fill concrete payments. This is another type of concrete payment, uh, CFCP, but only for low volume roads. Okay. So of course, design etc. are also available in the literature. This is also some papers also published, and these are also another concept that was propagated from IIT Kharagpur campus by our late Professor B.B. Pandey. So, in a nutshell, what I wanted to tell the audience is, yeah, these are some of the durable and innovative payments where sustainability is kept in view, and where there is a thickness reduction and the cost saving uh, through some using this same material, only minor modification to the existing materials are being proposed, and guidelines are being formulated and will be uh, made available to all the highway community, transportation community very soon. So this kind of approaches, we feel that we serve the community and benefit to the payment industry as well as to the users who are going to use it. Okay, so that's all from my end. Thanks, and I request the convener, of course, the course coordinator to pose the questions that they have from the audience. I am happy to clarify those.
Sir, you want to talk?
Yeah.
Yes, sir.
Professor Reddy,
Sir,
you know, today you have really discussed a lot about pavements and all, and it is, the bituminous part uh, definitely uh, is a totally different subject, and I believe that the concrete part
yes,
is
sir.
also totally different subject. Now, uh, I have got a few things to know from you that uh, from the consideration of your free carbon world, that is which in G8 summit and later on everybody has accepted. That you also told similar thing. Do you think that the flyers got some role to play uh, in developing your that kind of concrete?
Yes, sir.
Have you done any kind of analysis with
Yes,
your?
sir. No, sir. This you are talking about concrete payment, sir.
Yeah, I am talking
Yeah.
about concrete pavement,
Yes, sir.
and,
I have
and
not shown the analysis. We have done extensive FEM analysis, sir. FEM analysis, extensive.
no, only thing is that I want to know about the material that sometime people are adding fly ash with your conventional cement or in concrete to reduce the cost, and also it avoids the dumping problem. But now in 2020, India has published a code, IS code on alkali activated concrete, and that is long back people used to say geopolymer. Later on,
Geopolymer.
geopolymer. Later on, there's some confusion. Now it is alkali activated concrete, and in that name, already a code has come out, uh, 2020. Uh,
Sir,
if
this
you
sir.
uh, if you compare this type of concrete with the concrete, suppose normally we use or better quality of concrete you proposed, uh, I think it means this type of concrete may be tried.
Yes,
And
sir. Sir, concrete. So any concrete, see for the payment, sir, we work only M40 grade of concrete, sir.
yeah,
Whatever material that satisfies M40 can be used, sir. That is not a problem. We only propose the design methodology. Materials, what we have tried is a conventional, of course, PQC. They've also used some fly ash, all those things actually. But as you said, sir, geopolymer, concrete, all those things also can be there. Only requirement for payments is we want M40 grade of concrete, sir. That's all.
yeah, that is why I was in Jadavpur University,
Sir,
and now I'm with HIT after 65. You see, in HIT laboratory, we could develop geopolymer concrete up to M60, and we are trying to make it much better. Uh, so, if you think that this type of concrete is useful, then what we can do, we can go for some collaborative work where you can apply this concrete in your road surface, and the way you check up the performance, you can do that, and finally we will get another application,
definitely.
because normally we are using in buildings and other places. Another thing is that we have also developed porous concrete. Porous concrete means, when you are parking your car,
Yeah,
and
yeah, that is on, yes, yes.
so there is no question of drainage. Is automatically the water passes away. There's huge voids within the concrete, but the only problem is that in porous
Clogging.
concrete, the strength you are not getting,
Clogging and all, yes.
clogging and all. But this is also another type of concrete. What you can suggest, because sometime this water logging or this kind of problem is always there. So that is also another area where we are concentrating. And the one more thing you mentioned, that is, I liked very much, that is self-filling concrete. Self-filling concrete, we tried, but this bacterial concrete, it is sometime, the result is not consistent, because depending on the bacterial culture, uh, whatever the secretion takes place, it is not always uniform. So the self, of course, self-filling concrete can be done in other way also. So I think that all these three things came to my mind, because you are really working at the highest level. You are with the code, and if you think that this kind of areas, our teachers, Dipti and Abhishek, they are working in these areas.
Yeah, I'll share, sir, whenever like geopolymer and all, no? Porous concrete, of course,
You
here also
can,
one or two students have done PhD and all. But
okay,
anyway, that clogging, all those issues are there. But
yeah.
geopolymer concrete, no, geopolymer concrete. So I will suggest, sir, like uh, whenever some authorities are going to do some concreting work here, that can be taken up, sir.
And this most important thing is that the impact, that part also you can take up.
Yes.
That is very. Anyway, I'm really thankful to you for giving us such a, you know, good lecture. Good lecture, I must not say. I must say that a complicated thing you have presented in a most lucid way, and that is the thing what we expect from a person like you in a FDP program. And that way our today's program is successful, 100% successful. And we expect your help in future also
Definitely, sir.
for conducting research or conducting this type of program. And sometime I'll request you to visit HIT also.
In fact, I visited once earlier.
So
I'll come, sir.
have you visited Jadavpur University anytime?
No, no, no. Jadavpur, no, sir.
So if you come to Haldia, it's a mini Jadavpur.
Okay.
This is, the environment is good, very
Yes.
good. Not like any ABC private college.
Okay,
It's a
sir.
totally different college. Thank you very much, sir. Thank you.
Thank you, sir. Thank you for your work.
Thank you, sir, for your informative and interesting deliberation on the topic innovative and durable bituminous and concrete pavements for high volume roads. We, the faculty members of Haldia Institute of Technology, as well as all our participants, are very happy and overwhelmed with the session. Professor Reddy has discussed the major road infrastructure projects in India to start with. In this discussion, Sir has discussed how to eliminate the poor geometrics in and how it is important to improve the right quality. Sir emphasized on building durable roads and also discussed about the jointed plain cement concrete pavements. Sir pictorially showed and represented the concrete pavements performance by showing the concrete failures due to cracks, and also recommendations to repair them by stapled rehabilitation methods. Sir has discussed about short slab concrete pavements construction on NS 18. Sir also gave us glimpses of draft IRC codes guidelines on design of short slab concrete pavements for highway and expressways. Exposed aggregate surface for concrete pavements was a new construction technique we came across today. Sir also explained about the flexible pavements and their layer thickness, how to reduce it, and as per guidelines, how we can go ahead. Sir also explained about the stone mastic asphalt and cement grouted bituminous mix, which is used in many areas. Sir detailed about new technologies like HIMA and hyper mixes used in flexible pavements construction. foam bitumen and self-filled concrete pavements are something new we learned today. I think this detailed discussion will help our participants to enhance their knowledge in new techniques in pavement construction. Sir, your presentation was very well organized and detailed and with a very understandable language and all real-time images which attracted everyone. So again, on behalf of the organizing committee, I am thanking you, sir, for this important discussion. Thank you very much.
Thank you, sir.
Thank
Thank
you very
you,
much.
Deepti, and thank you, Professor Somnath Ghosh, and other participants. And if any, of course, clarification required, please let us know. We will definitely share those, provide adequate replies for that.
Thank
Thank
you,
you.
sir.
Thank you. All the best, sir.
Thank you very much.
Now I would request Atreyi Bandopadhyay ma'am, who will be taking ahead the session's question answer session, which are posted in the by the participants in the chat box. Over to you, ma'am.
Thank you, ma'am. And thank you, sir, for the wonderful and beautiful lucid presentation. For question answer session, I would like to invite the faculty members, in-house members. If anyone has any query, please go on.
Actually, I have already expressed my mind, but you don't have time probably.
It's okay, sir. No problem, sir.
Sir,
Thank you,
I
sir.
have one question.
Yeah, please.
Sir, coming to this bituminous pavement, which we saw, in that you mentioned in Haima mixes, you are adding some polymers,
Yes.
some modifiers.
Yes,
So,
yes.
what are those, sir?
No, what we gave was no. See, when we prepared a guideline, we tried some polymers. Okay, some polymer like EVA. Okay, ethyl vinyl acetate. Okay, and also some SBS polymers we have added. And of course, in the guideline, what we are doing is now when I add one or two polymers, if I name, so then people may think that only those polymers. So what we said was you can use any polymer, okay, taking a general guidelines on the polymer, and you can add any polymers to get that bitumen. But the one which we have added is EVA polymer, EVA 28 and EVA 18. Okay, so that polymer means some dosages. Of course, I have not told you that dosages and all here,
Yes.
but if you want, I can give you. But in the guideline, we have not given any dosages because if I say dosages, why not other? Because other polymers also may satisfy the requirements. So we
There's
only
always
give specifications. We said that any polymer, any dosage that satisfies these requirements, they may use it. But
so
for
one.
information, if you want, I can share what doses that we have added. You can try in your lab also. Just simply take those dosages and test penetration softening which are available and see that whether you are getting those properties. Though you will not be able to do DSR where G star by sin delta.
Sir, one more question I have. As we already know, flexible pavements offer good ride quality. In jointed plain cement concrete roads, won't it affect the ride quality as
Right.
we are compromising the surface smoothness?
Yes. So now that is a question everybody asks actually because we are having more joints. But here the joints are very thin. Joints are only 3 to 4 mm. So you write the thing because this is a best explanation is if somebody goes to Bangalore, those I think most of them may have some connection with Bangalore, either their daughter, maybe somebody is working or somebody is there. You go to nice road, just drive on nice road. Like people are going with more than 120, 130 kilometers per hour. And last 10 years, no riding quality effect. Though it appears that physically we are cutting at a number of places, as you know, joint width is more, then you will have an issue. But joint width is only 3 to 4 mm. So that doesn't cause any effect. It is like conventional. Of course, noise will be there, that is there. But effect of joint, noise, it is not there.
Professor Reddy, are you, filling the joint by
No, sir.
polystyrene?
Yes, sir. So that was another question, sir. Because what we tried was, we tried filling with some joint with some filler, without joint also, without filling also.
No,
We did not
without
find any
feeling,
difference.
no, but if you fill with some material, is it polysulfide sealant or
No,
something
we
like
have
that?
that joint sealer, but we have not. We There is a joint sealers are there, sir. Some commercial products
Okay,
which are
okay.
used for that, which have got that flexibility, expansion, contraction, all those things.
Is it bituminous or polymer based?
A polymer based, sir,
Polymer based.
there.
Right, right.
And here we tried, but we don't find any difference between one which are filled up with the joints without also, because of gap is 3 to 4 only.
Yeah, yeah.
That's why we are not recommending any joint fillers here.
No, because your base is very strong.
Yes, that is the main thing. So base is very strong.
Very strong. Thank you, sir. Thank you.
Thank you, sir. Thank you very much.
Okay, thank you. And if you don't have any questions, I will take
Thank
a
you,
leave.
sir, and thank
Thank you
you,
No.
very
ma'am. And yes, sir, there are no many questions anymore. So thank you for your wonderful time and presentation and valuable time and presentation. Hope to meet you and work with you future again.
Sure, sure, sure.
Thank you, sir.
Sure, all
Have
the
a
best.
great
Even
day.
if you have any doubts, you can write to me. No issue, we'll clarify.
Sure, sir. Thank
From
you, sir.
also for all the
Thank you.
participants as well.
Thank you
Thank you,
very
all
much.
the best.
Thank you.
Once again,
Thank you.
okay,
Thank
sir,
you.
I'll just take a leave.
Okay.
Okay.
Thank you. Now, for all the remaining participants, I thank you all for your presence in this session. Dear participants, please note that our afternoon session, which is the last session of our 5-day FDP, will start from 3 p.m. It will be a very interesting lecture on the topic of research methodology by our own Dr. Somnath Ghosh sir. Please join the afternoon session 5 minutes earlier the scheduled time. Thank you. Hope to see you again in our next session.
Good afternoon, everybody. Show me. Good afternoon. Am I audible?
Yes, sir, you are audible, sir.
Okay, thank you.
Yes, sir. You are there. Everything is fine, sir. Connection.
It's okay.
Okay, sir. So we are starting then, sir.
Yeah.
Good afternoon to all respected eminent speakers, organizing team and participants. Welcome back to the last session of the day of 5-day online faculty development program on recent trends in civil engineering, organized by Department of Civil Engineering, Haldia Institute of Technology, Haldia. Today, our second section of the day is on the topic research methodology. The speaker for the session is none other than Dr. Somnath Ghosh. Sir has earned his BE in Civil Engineering from Jadavpur University, Kolkata, and subsequently completed his MTech and PhD from IIT Kharagpur. Dr. Ghosh is a member of Institutes of Structural Engineers, London, and holds an MBA degree also. Sir has served as Dean of the Faculty of Engineering and Technology at Jadavpur University and also served as the country head of a division of the entire civil engineering department of Haldia Institute of Technology. I welcome you, sir. We are thankful to you for accepting our request and gracing the occasion by your presence. Over to you, sir.
Thank you. Please come. Beautiful. Well, thank you, Show me, and thank you all my faculty members, HIT administration, and my other friends within the country and abroad. I'm really, you know, happy that you have given me an opportunity to discuss few things about research methodology. As you all know, that research methodology is nowadays became a compulsory subject to the researchers. Uh, Frankly speaking, that when you will be going for a higher degree, maybe PhD, and if you talk to your teacher, he will immediately say that complete research methodology within 1 year, because that is the requirement for getting PhD degree now. Without that, within India, many reputed institutes and other institutes also, according to rules and regulation of the MHRD, they don't consider their PhD degree. So research methodology is a compulsory subject at the PhD level. And also you will find slowly that in master's degree level or even maybe B level, uh, this particular subject will be introduced. Maybe in the B level to some extent, MTech to a great extent, and in PhD level at the highest level. Now you see why this subject is so important. Why this they are making rules. We are making rules. Now, question is very simple that in our country that you will find that research is sometime people are doing just to get a degree. But after getting the degree, most of them they don't even remember their research work. Sometimes they forget also. But those who are going to the research institutes or education institutes, there again he or she is doing research. In many cases, it is found that is just to get promotion or some other facilities. But this cannot be the objective of research. You cannot force anybody to do research. And the researchers who contributed a lot, and that's why, people are trying to go to the moon. That is different. We want to know science. We want to develop our innovative ideas. You heard about, patent. Even if you try to know the story of KFC or McDonald's, you will find that they made patent, and after that, slowly, they have extended their business, and now they are one of the giants in the food industry. And you can easily understand that this is happening because of their patent. And the patent, they have earned it or they got it because of their production. Whatever they have produced, that they have patented, nobody can use that recipe. And if they use it, in that case, they have to pay to the McDonald's or KFC. So that is why the companies or the particular organization may be in a particular part of the world, in a particular place of the world. But with the strength of patent, they are ruling the world. They became the king in the field of food technology. So you can easily understand that one way of thinking is, I have to do some research, otherwise I won't get PhD degree. The other way, yes, I want to do something, I want to go into the deeper part of my subject, and if I can contribute something which will make me happy and also help the engineering fraternity, science fraternity, and society as a whole, perhaps that should be the goal of a particular person. So that is why, nowadays the academicians, the administrators, they are giving lots of emphasis to research methodology. So today actually I'll be discussing different facets of research methodology. But truly speaking, that it is such a subject, even if we discuss for 7 days, it will not be finished. This is, you have to understand it. Second thing, that those who are not doing research, they have to first appreciate the objective of research. Why they are doing research? The way I explained, whether they are agreeing that or not. Otherwise, whatever we discuss, nothing will come out. It will be just a 2-hour lecture, and after that, everybody will forget. But even then, we have to do our best. We have to do the justice to the subject, because even the 5% person, if they are, they think after this 2 hours lecture, and if they can organize their research in a better way, perhaps that will be our success. So with this, let me first come to this research methodology. Is a way of explaining how a researcher intends to carry out their research. It is a logical, systematic plan to resolve a research problem. A methodology details a researcher's approach to the research to ensure reliable, valid results that address their aims and objectives. So, you can easily understand that you are talking about some methodology. Now, if you really think about it, and if you really try to understand deeper part of it, and if it is coming from your heart, then the methodology will be very strong. You are very sure where actually you want to arrive. And for this, it is not that in one fine morning, if I decide that I'll do some research, and out of the research people will be benefited, and you will be, ruling the earth. No, it is not possible. It is not possible. You see, if you are really knowledgeable means if your basic knowledge is good. Basic knowledge good means if you are a man of arts, it is different. If you are a man of science, engineering, then it is different. So depending on the subject, if your basic is clear, if you have learned it in deep learning is very important. In that case, your methodology will be in the right direction. You cannot really just develop some methodology, just anything. No, you can't do it. This particular lecture will help you that how you should think, and finally you will arrive at a particular methodology, and accordingly you will pursue your research, and with your outcome you will be able to win others' mind, and you will be popular in the society for contributing in a positive way. Now, you see, when you are saying that it is logical, systematic plan, obviously Anything, if it is not logical or systematic, it is not possible. And at the same time, whatever you are doing, you have to ensure reliable, valid results, aiming at your objective. Because in many times, when you are conducting experiments, we are not getting, suppose, the result what we are expecting. Maybe you are trying again, again, and again. But even then, you may find that it may not be, or it may not tally with your understanding. Now, it is quite possible, because the way you are thinking, maybe that phenomena is not happening that way. So how come whatever you are expecting, that is always correct? Now I tell you a very small, science story that many of you are also familiar to that. That is Davidovich in France. He started working on geopolymer. At that time, the most of the works, it was on geolite. Later on, after 15 years, he extended that kind of concept in case of cementitious material, which we are using in civil engineering, and he has thrown, light to the researchers. Even today, you will find that many people are following his guidance, though at the present moment, Provis from Sheffield University, their way of thinking or their concept regarding this kind of alkali activated concrete, means which David used to call geopolymer concrete. They are saying, no, you cannot say it's a geopolymer concrete or the polymeric reaction is taking place. No, you can't say. Obviously, in the beginning, Davidovich said that, I have seen in the YouTube that Davidovich is saying that they should work more, they should have better understanding about the subject. Otherwise, they are making mistake by stating this kind of sentences. Now, obviously, Davidovich, whatever he developed, he was very sure about it. But later on, Provis, he is also extremely sure. The age difference is 30. Now, I was trapped in this debate. How? One of my PhD students, he has sent a paper to ASTM. And the ASTM, after reviewing for several times, ultimately they said that whatever the contribution you made, that is fine, everything is acceptable, but only thing is that we are not going to accept the term geopolymer. Why? They are saying that when you are adding slag to this fly ash and alkali, then the geopolymeric reaction is not really taking place. Some other thing is taking place, which the Davidovich has not rightly pointed out. So whatever he said, the similar kind of reaction mechanism is not happening. So it's a big statement. and they requested me to change the term geopolymer to alkali activated concrete. Geopolymer concrete, they don't want. They said that you replace it by alkali activated concrete. But they may say many things. I am in a developed country. That doesn't mean that I have to accept every scientific interpretation made by them, unless I appreciate it personally. We are poor, but we are scientifically strong. Our science knowledge, mathematics knowledge, I believe it is no way less than anybody in any part of the world. Now, what I did really, I said, you give me some time and I'll give you the answer. I went to the science college in Kolkata and requested them that can you help me? What kind of really reaction mechanism is happening? They said yes. Why not? They said mass NMR can be conducted and many other tests can be conducted, and ultimately we will be able to tell you that whether polymeric chain is formed or not, or otherwise what is happening. At least we can indicate. Now I said I am interested because of this. So they said okay, no problem, even if a lot of money is required for that particular test. But our scientific fraternity is very good. They are always with us, helping in different way. Our friends are also there. So anyway, with little bit of expenses, they have conducted test, and ultimately they said that when you are adding slag, the polymeric chain is not really found clearly. And they also said that when you add, when there is slag, then CSH gel is formed, calcium silicate hydrate gel is formed. But when your fly ash is coming in contact with your alkali, then aluminosilicate gel is formed. Now, in this particular case, it's a combination of these two. So the continuous chain, polymeric chain, is not really fully visible. So immediately it realized that whatever Provis is saying, yes, at the present moment, we have to accept it because we don't have much data about your reaction mechanism when fly ash and slag both present, and we are doing alkali activation. And I accepted that, and I wrote to them, yes, I'm ready to change this geopolymer concrete to alkali activated concrete. And my paper immediately got acceptance. Again, I wrote another paper that is also immediately accepted. So what I want to say, that you have to be very sure about your research. It is not for a PhD or somebody's PhD or a paper. It is not that. If you think in that way, then whole philosophy is lost. That is not the way out. When you are doing research, then I think it is not a part-time job for 2 hours, 3 hours, for 3 years. It's a lifetime job. When you are getting up, immediately it may remind you that what exactly you should search for, how you should prepare yourself to understand that particular subject. Not only that, you may be anywhere. You may be in a social gathering or in a particular place or in a particular place, but your research will be always in your mind. You are always carrying that. You are always carrying that. Yes, that kind of, you know, situation or that kind of mental environment is very much required. Very much required. I can tell you at the age of 67 that I try to live in this kind of environment. Though I am doing other works, but still I want to live in this kind of environment. Now, you see, then what is research? Research can be defined as the search for knowledge or as any systematic investigation to establish the fact. This is the example I've just given. It is just to know the exact fact. What happened? What was the, this exact reaction mechanism? And for that, you have to search for knowledge because your knowledge is not sufficient. Anybody's knowledge is not sufficient. Naturally, you have to search for knowledge, you have to get the knowledge from others, and then you have to go for a systematic investigation. And here comes the role of research methodology. Systematic investigation. Now question comes that if you discipline, if you are honest, then only you will be able to produce something which today or tomorrow people will accept and practice. Otherwise, if you do something without any hard work, sincerity, then today or tomorrow people will realize that this person is not honest, at least in research. So how can we rely on him? So research means we have to be 100% honest. Even if you are not getting your result, don't do anything. You may come out with something else. Now, I tell you another story. You see, in 2006, somebody gave me, the like of clay is available in the bed of river Ganga, which we are saying in Bengali poli, and that they gave me and they said, "Sir, can you develop some kind of brick out of it, or anything which has got a high composite strength?" I said, "Okay, give me that packet because it's a small packet." And what I did, immediately I went to the laboratory. My students were always there because I am lucky that way, because when I was in Jadavpur University, every time at least 4 or 5 students are around me, research students, MTech, PhD, like that. So I was in that, even the BE students are also, after with me. And I can't say that I never got support from anybody. Yes, for them, I could do something. Now, what I did, I have mixed that particular material, which in Bengali called poly, mixed with lime, and made a small piece of brick, and then I kept in the furnace, and we decided to take out next day. After that, we forgot everything. Means it is in the furnace, next day we should take it out. Everybody, my students, myself, everybody, we just forgot. We concentrated in some other work, some other material. After 3-4 days, suddenly I said, we have to take out that brick. And we took out that brick, and we found that a portion of the brick is extremely hard, like rock. And the remaining portion, a small portion, that is has got no strength at all. And then we started thinking that why it has happened. You see, the reaction is supposed to take place under the temperature, and the temperature environment was not even, not uniform. So a portion got that exposure which we thought about, but remaining portion, no. As a result, this thing happened. And you see, the material which we got very hard, like rock, in Bengali we call koshti pathur. So immediately it came to my mind that what are the components in poly in that particular material, and what is the kind of reaction we expect when you are adding lime. And then why not we can convert fly ash to this kind of material. Immediately I talked to my friend in Titagarh. We brought one track of fly ash, about 50 bags, because every time we will not go, kept in a particular place, secured in plastic bags, everything. And we started working on it. And at that time, master's degree, PhD, maybe 4-5% they started working. Even undergraduates, they also started working. And within 3-4 years, I could realize that yes, I got something, and which I can take forward in future. In the meantime, I got the assignment in Africa, in Nigeria, and I joined there. But every day I used to talk to my research students and others, undergraduate students, and discussing about this, and our work never stopped. It continued during that period when I was in Nigeria. And slowly, in 2012, 2013, we have reached to a stage to write books. And we started writing book. And slowly, we could publish 3 books on this particular subject. Now, you see, whether we could publish 3 books or 50 papers, that is not the issue. Because in my age, I have got everything in my life. So in my age, if I get some kind of satisfaction, happiness out of this research, that is only God can give me. And probably He is with me. Now, you see, what is the difference between methods and methodology? Because you have to understand every word, and then slowly you can build your research temple. Methodology is the overall strategy of your research. Overall. Method are procedures like survey, experiments that you use to collect data, analyze your data, and where does methodology goes? Where it will go? You will be preparing a report with your results or something, maybe preliminary results, because without this, you cannot forward it to the scientific fraternity. Why? Because if you want to pursue this research further, then you need funds. Funds means MHRD or AICT, UGC, many organizations are there. But you have to develop this methodology and you do a little bit of work and you may have to publish 2, 3 papers. After that, if you write a report and send it to them in proposal form, and after that they may ask you some question on that. And in most of the situation, I found the questions are basic questions, which if somebody has learned in class 9, 10, 11, 12, fine. Otherwise, he will not be able to answer. So that's why I sometimes find that the schooling is very, very important, because there actually we have learned physics, chemistry, mathematics, and also a little bit of English. And without this, you will not be able to really answer those questions, because they are not asking very difficult questions. Very simple, basic questions. I also ask simple questions when I am going to assess somebody. Now, the question comes that this report you are submitting, you are getting the fund, and then according to your methodology, you have to proceed, and finally you have to give a final report. It may happen that the methodology you have decided initially, based on your review of literature or your knowledge, basic knowledge, or your intuition, you may have to change a bit. That is not a problem, because if you change it for a better technology, it is always, people will appreciate. So this is the difference between method and methodology. Now, why is a methodology important? Sharing your methodology gives legitimacy to your research. An unreliable or erroneous methodology produce unreliable or erroneous result. So that those people wants to check that, because they are giving you a lot of money and you will be doing research. Without money, you will not be able to purchase any sophisticated instrument. The money at the present moment is not a problem. Funding is not a problem in India. Problem is that the way scientists are presenting things, it seems that, or sometimes we feel that they don't have good knowledge in physics, chemistry, and mathematics. Even I tell you that when I'll be discussing more, you will slowly understand that English is very important. Why? Because though they don't expect that very high level English, but they expect that you should be able to explain it properly. Because English cannot be the barrier. Language cannot be the barrier. When you are representing something in front of 20 people, it is your baby. Naturally, you know much about it. So, if you don't have any language barriers, obviously you will be able to convince them in your own way. After that, you have to face questions. And if you are wrong, if you are in wrong track, you have to change it. You have to accept their proposal. It happens. It happens. Even suppose you have asked for 2 crore. They are ready to fund you, but they said that we will not give you more than 1 crore, so make your budget within 1 crore. If your research is successful, then we may extend more support. So you have to understand that not only your intuition, not only your deep knowledge in the subject, but also the reality that if you ask for 2 crore, they may not be able to give you. You see, now we are thinking projects in terms of crore. In my time, when I started my research, even 5 lakhs is sufficient. Sufficient, a big project. And not only that, now defense is giving huge number of projects. It is 3 crore, 4 crore for some project, even 20 crore. And this is why I know, because at Jadavpur University, people used to work on defense project. When I was dean, I was the chairman of that particular committee. So I know how much money got IIT Kharagpur or CSR, means our CGCRI, Jadavpur University, how they got it. After how many rounds of presentation they got it, and why they got it. So that is why I tell you that normally I never say anything which I have not appreciated in my life, because it is not possible for me to repeat somebody's word. No. If I really appreciated something, if I know the fact, I have seen, I have gone through it, or I was within that process, then only I normally give that example to my juniors. Now the reader of your research expects, what they expect? You to have followed accepted practice so that the conclusion you reach are valid. That means, suppose you are going for some kind of testing which is not yet in the code, or not yet in the guideline, or not yet recommended by any task committee. Sometimes they argue on that, but it is not that always the methods, the experimental methods will be as per some guideline or code. It may be totally your concept. Yes, it has happened to us. For geopolymer, one of my students, Devobroto, he suggested a method which was not in the code, but later on we found very good interpretation from that particular method. Who knows, in the next code it will be included. So I am not saying that you will not put forward your own idea of testing. Yes, you should. But at the same time, you have to follow the accepted practice. Otherwise, it is in the initial stage, it is difficult for you to convince the other side of the board table. Now, methodology, your report need to be repeatable, and meaning, anyone who uses the methods you write about should reach to the same conclusion. Means whatever you are writing or you are proposing, if they do that kind of thing, they should get near to that. And there comes the reliability. That means the person who are assessing you, they have got some knowledge, they have got some experience. With that, they will always try to understand that what you are proposing, that is meaningful. It may happen, though they have not done it. no problem. But if you claim something which is not at all possible, at least with if you apply your basic knowledge of physics, chemistry, mechanics, or mathematics, no, in that case, they will discuss with you. They will try to know more about it. So the repeatability is very important. So when you are writing a particular methodology, before that definitely you have worked on it or you have seen the others work. So it is happening. But frankly speaking, there are two schools of thinking in this area. One school of thinking is normally practiced in Europe, Australia, New Zealand, and the other school of thinking in US. In US, whatever they think in the morning, some intuition, something coming to their mind, immediately they try to do it, try to have a project on that. Japan, same thing. And that's why you know that in Japan, in US, many patents are there, which is only the concept. They have not done any work. They only thought about it and they patented. So just think about it. But in Europe, it is not like that. In Europe, they go through the others' work. Now slowly they are changing their mind. And then they are deciding that what should be their next step. Unfortunately, number of patents in India is extremely less. Now it is increasing. The idea patenting or actual patent, now it is increasing, but still it is not comparable to Japan, US, and also to some extent to Europe, Australia, New Zealand. So this is the thing, you know, you have to always think in this way. You see, if you do something, if you got a patent, maybe it will help you to get the next higher post. Yes, that should not be the attitude. You have to just do it. And if you get some opportunity to make patent, make it. And let the other people assess you. Automatically, you will not be only promoted, you will be respected. Promotion is something which will give you maybe more money, status, but the respect, it is something different. It is something different. We have to run after the respect with our hard work, sincerity, and honesty. Without that, it is not possible. Now, you see, our this writing a methodology, I'll give you some tips. You have to show that how and why. Go beyond a simple description of your methods to show how as well as why you use them. This helps demonstrate that you rigorously conducted your research. A kind of feeling should be developed in the mind of persons on the other side of the table. Then draft as you go. Take note and outline your methodology as you work to make sure you capture all details accurately. The better you record your methods and techniques in real time. Let me tell you few more tips. Focus on your research questions. Very important. In many proposals, they are, giving some research questions. Relate your methodology choices to the central theme of your research. Try to understand. Central theme of your research. So suppose if somebody wants to do something or government wants to do some kind of research and development for agro waste. So that is the central theme of the research. Or the agro waste ash, not only agro waste, ash. That is the central theme. So whatever the proposal you will be given, you give that will be always that. I'm not naming investigation, particular we tend to this, that is not our department, but what happened that your many is not what is other part they are matching. So this kind of problem anyway they are rewriting it and maybe in future this kind of not there. That's why I said that choices to the central theme of the research of your research. Very important. This shows that you do the best method the diseases, which is the outcome of research. Right for your craft that is clearly written and well structured. Address the audience research with good writing. I'm not saying that the person who committed not like them. Like we're engineers, scientists who have studied English or class 11, doesn't matter. Even you can write good English because that is the wing language. So you don't have an option. Providing more than a list of technical activities. You provide that activities very everybody. Now, unknown any living of your usual practice in your field, clarify your choice. Never. That's why I said that everything will not be in the code. I was talking about one of my students.
There seems to be some connection issue. So, shall be connecting in just wait for a few minutes. Dear participants, due to a network issue, Sir is not able to connect with us. So kindly bear with us and wait for a few minutes. Sir is trying on his end.
ठीक है चॉइस
Yes, sir.
ये किस में
Now your voice is audible, sir, but the video
audible?
connection may be audible, sir.
No,
Audible.
that's the file called me that now it is audible, no?
So it is audible, but the network issue is there.
So your voice is audible, but
Okay,
it's
so what can I
breaking.
do?
It's not
Yes.
continuous, it's breaking.
But I don't have a good computer like you. So what can I do at this
So
present
maybe there
moment?
is a network issue.
Issue, sir. It's internet issue, I think.
Maybe
Maybe.
there is a network issue. Okay, sir.
Yes.
What I can do, I can change my, this one. Um,
So please share the screen which you are presenting.
Is it better?
No, sir. Please share the entire screen, sir.
No, that I'll do, but I am talking about the voice.
Sir, it is still breaking sometime, but it is better now.
It's better because this particular mobile is a bit costly. So that's why I'm getting some advantage out of it. The other
Yes, sir.
mobile,
Sir, now you are very well audible.
oh, fine, fine. Thank you very much. Now I can continue again. So I was here, is it not? I don't know where I was. I was here or before
No,
that?
sir. No, sir. Sir, please keep on.
Here.
Yes, sir.
I was here probably. After that, problem took place. Is it not? Or even before that, here.
No, sir. This is sir.
Tips, so you got it.
Yes, sir. Yes,
Huh?
sir. This one.
Previous one. This one.
Yes, sir. Yes, sir. Here.
Okay.
Yes, sir.
Now you see this focus on your research questions, because in the proposal there may be several questions, and relate your methodology choices to the central theme of your research. Now, central theme of your research means that the central theme which they provided, because just few days back there was a central theme, something on this agro ash, and we propose to develop some kind of material out of it. But before that, mechanical, chemical, also they also have given some proposal. It was a combined proposal. But what happened that whatever the logic they have shown and the way they wanted to do it, that was perfectly all right, and it was in the methodology, and it is directed to the central theme. Ours also same thing. It was also directed to the central theme, but there was a disconnection. The experts, they have separated these two portions. They said that that is one part, and the civil engineering given another part. Both can be given for research, but it should be, you have to rewrite it. Anyway, so this thing happens. So that's why your choice is to central theme of your research. Second is your, the right for your audience. Craft a methodology that is clearly written and well structured. Very important. Address to the audience of your research with good writing. You have to be, at least, to some extent, you have to good in English. Not like, a person who completed his honors in English, but an engineers, whatever we have not learned anything on English after your higher secondary. So that is not an issue, because after that we have gone through different books, we have seen different movies, English movies. So we have got some, knowledge to express our mind in English. So anyway, so what I'm saying that good English, good writing, not excellent. Good writing is sufficient, providing more than a list of technical activity. Now this is uncommon technology. Uncommon technology, I was talking that I have already told you that the methods the experimental methods, it should follow a particular code which is already practiced. But suppose you are proposing something which is not practiced. This doesn't matter. You can propose even that. But you have to uh, uh, you know, strongly give some reasons behind it. Strong reasons. Or whatever method you are suggesting, in favor of your method, you must be able to convince them. You avoid criticism. So it is always happening for unusual methods. But still people are doing it, and in this way, from one code to two codes, now there are 2,000 codes in India. India is a country who has got huge number of codes. A small country, not like US, and not much money with us, but still we have got huge number of codes, and we have developed those codes from our research, and also many things we are pointing out which are not in their code. I'll show you that something is there in our IS 456 which is not there in ACI 318 or BBS 8110 British code or in international code, FIP codes. Now, describe how you collected the data. This is also important. Or you will be collecting data. So, report whether you used quantitative or qualitative data for your research. It's very important. In your concrete research, you will find that durability is still today, it is qualitative. But when you will write a paper and send it to some good journal, they will say, no, try to quantify it. And it can be quantified. There are methods in ASTM and other, and through that it can be quantified. And in one of my geopolymer paper, I have quantified this durability. So it is not always qualitative. Describe any experiment you conducted, including how you designed the experiment, how you measured any variable, and what tool you need to conduct the experiment. Very, very important. Explain how you source your existing data, including how that data was originally gathered and the list of criteria you used to choose existing data from other sources. Please go line wise. Every line is important to you. Got my point? If you appreciate every line, then you will never do any mistake. Now, method to analyze data. How you process and analyze the data, whatever you have collected. And ultimately you will conclude. And it will be strictly quantitative in engineering. Qualitative, yes, sometimes it is qualitative, but we expect quantitative. And list the steps you took to ensure the data was accurate. You have to write down, yes, my data is correct. Suppose somebody is working in finite element, and suppose he is getting the answer by closing the mesh. Of course, if you close the mesh, then there will be many other mathematical problems may arise, time, many things are coming. But still then, if you can justify, then it is fine. Then it is acceptable. Suppose there is a plate and there is a hole at the middle of the plate. Now, obviously, due to stress concentration, your meshing near the hole should be closer. No doubt about it. But Professor Krishnamurthy of IIT Delhi, he died in an accident. He developed an expert system. Using that, the mesh becoming automatically closer as required near the cutout, and will give you the best result. So that's why I tell you that the accuracy you have to establish. You can't say my thing is best. No, you have to justify it in different way. It can be justified. Any software you use to analyze the particular, anything, maybe huge data is there. You are analyzing that with a particular software. So you need some statistical testing. Otherwise, you are not sure. If you use purely qualitative research, and your analysis may be content-based, theme-based, or discourse-based. So this is the difference. Now, evaluation and justification, the methodological choice. Describe the criteria you used in choosing your approach to your research. List potential weakness in your methodology and present evidence support of your choice. Include a brief evaluation of other methodology you might have chosen. It is very, very important, because anything you are doing, you know what is the drawback of that. Anything you have developed 5 years back, maybe now you may want to change it, because when you developed it, you know that you have not considered many things. So it's a continuous process. It's not that you have completed your PhD means everything done. No, it's just a passport that people will consider you as a researcher. But after that, if you don't do it, it has got no value. It has got no value. It sounds bad, but that is the reality. Because everybody wants that, what is your present contribution? What are you doing? What are the new concepts you are bringing up? What is your activity? Now, obstacle and their solution. Outline any obstacle you encountered in your research and list how you overcome them. Means it may be you are anticipating, or maybe you have already faced that kind of obstacle. The problem solving skill you present in this section strengthen the validity of your research with readers. Readers means in this case the person other side of the table. Then the citation, all sources used to determine the choice of your methodology. This is very important. You can always present your research methodology and say this is the best. But in that case, you are not citing others' work, because you got some idea from other works also. You should acknowledge the final selection of your methodology references the sources you use when determining the overall methodology. This reinforces other the validity of your research, is it not? If you say that many people have done like this, they got like this, but these are the pockets where there is some problem, and we should try to come out of these problems, and that's why this is my suggestion, that if we do like this, then this will be better. That is better. At least you are referring somebody, means you know about that, and then you are proposing. Not that you are only proposing without knowing anything. This is sometimes happening for Americans. They don't want to study other works. But Europeans are different, at least whatever I have seen, that they go through the literature thoroughly. That doesn't mean that they will only extend their work. It is just to appreciate, just to strengthen their proposals, research methodology. You see, just few years back, when I thought that after my retirement, means after 65, I'll be joining some research group, and that's why I sent at the time that proposal went to Ireland in a particular university, and that's to get a European project. European Union project is very good, huge amount of money they are giving. And when I prepared that proposal, just before Corona, and it was decided that I'll be reaching there in April. Everything was set, but Corona started, and naturally the entire thing is we could not proceed for 2 years. Now, when I developed it, maybe the thermal conductivity of geopolymer concrete, many people they have not worked. Maybe in Ireland, Oliver worked a lot, but whatever I got it, accordingly, I have analyzed it, and then what will be my research methodology that I presented it. Because only referring their work is not sufficient. You have to analyze that, and you have to find out the pockets where some more research is required to make it more correct prediction models. And so those things are required. So that's why citation is important. Now I tell you the characteristics of research: systematic, logical, empirical, reductive, replicable. I have already discussed these things. Now, regarding your, you can say, the steps of research process: identify the problem, review the literature, clarify the problem, clearly define terms and concept, define the population. Population means how many experiments you will be conducting. In other research, population has got different meaning. And develop instrumental plan, collect data, analyze data. So these are the steps of research process. Now, what is the difference between quantitative and qualitative research? I told you already. The quantitative research uses numbers, the statistics to test a hypothesis through data collection and analysis. Qualitative research explores ideas and experience using words and meanings. So in our case, the quantitative research is expected. That doesn't mean I'm saying that qualitative research has got no value. No, I'm not saying that. At least initially to appreciate that is very much important. But ultimately in engineering, the quantitative research, prediction models, all these things are required, mixed design methodology. Otherwise, people will not be convinced. Now, regarding this qualitative analysis, there are many things. There are different sampling methods, and many things are there. I'm not going into that right now because I have already, taken a huge time. But let me see. Let me first go to the end, and then if I get time, I'll come back. Then the quantitative analysis. You see, quantitative analysis uses number statistics to understand frequency, average, correlationship, right? Cause and effect relationship. All these things very much you are familiar with. So you have to collect data, and the data may be totally random in nature. If you go for compression testing of 30 cubes, you will get 30 different results. And from there, how many results will be considered for, statistical analysis? That is also another thing. Which one you should not consider? Maybe totally, maybe out of 31 is odd. So there are methods through which you can eliminate odd data. And then you have to analyze the remaining data, maybe standard deviation, etc., you will get. Now, you see, when you are going for mixed design, then you have seen that if the target strength is more, say 20, 25, 30, 35, then you will find the standard deviation. That value is also increasing. Why? Because when you are targeting to higher strength, the uncertainty involved in the process is observed more. The randomness is more of the actual data, the actual composite strength. And from there, if you calculate the standard deviation, then it is found that for higher strength of concrete, in high strength concrete, the standard deviation is more because uncertainty involved in achieving this concrete is more. So that is why if the standard deviation is more, then your target strength will be more. Then you can expect that at least you will get the strength which you are expecting. Now, this is another thing, that single blinding, double blinding. You see, these are the things, these are the concepts we are using in different purpose. When somebody is, working with a vaccine, then single blinding is sometimes not acceptable. People are not accepting. But double blinding, when the researcher is administering the experimental treatment, are aware of each participant's group assignment, they may be inherently treat those in the control group different from those in the treatment group. That means when you are applying in a particular group, you are getting some result. But the same thing we apply in another group. And if it is found that is okay, then it is okay. So it is double blending. Double blending. Same thing is happening in concrete technology. You are experimenting a particular set of data with, say, alkali content 4%, 5%, 10%, like that. And you are arriving at a particular prediction model, and later on, you have taken 1.5%, 3.5%, maybe 9%, which you have not considered earlier, and then you apply your prediction model, which you developed from your previous results, and if you find that they are very close to each other, then that means your prediction model is good. It is validated. People will accept it. So this could reveal to participants their group assignment or even directly influence the outcome itself. So double-blinded experiment, the group assignment is hidden from the both the participants and persons administering it. You see, it is happening in case of vaccine also. And if you think in terms of concrete, just now I said this is the way you can think. Then triple blinding, although rarely implemented, but triple blinding studies occurs when group assignments is hidden not only from participants but from administrators, but also those tasked with analyzing the data after experiment has conducted. Researchers may expect a certain outcome and analyze the data in different way until they arrive at the outcome they expected, even if it is merely a result of chance. So it is definitely, you can appreciate one thing, that the, these things are applicable to the situations where things means results may be highly random in nature. Whenever it is highly random in nature, the hour 2 is probability. And when you are applying that, then the more the variables means single, double, triple, like that, then obviously it is very difficult to get a result converging to a particular point. It is not that easy. It is not that easy. Suppose for a particular random data, there are this particular phenomena depends on 3, 4 parameters, and each parameters has got a some probability density function. Now, if we combine this, if we combine two parameters, their probability density function, then probably we'll be able to handle 3, becoming difficult, 4, 5, much more difficult. And naturally, when it will be, in terms of dimension, means length, breadth, height, and time, then it will be very, very complicated. So that is why, that sometimes we think about the many concepts, but it is not always possible to arrive at a particular conclusion, right, which is acceptable to everybody. But I can tell you at least that if it is very close to the actual one, then one can implement. It is not, you can always find fault, but if it is 90%, 95%, okay, then I don't think there is any reason to reject it. Now, this is another example. It's a vaccine case. This is another, like that. I thought that I'll be able to share, but time is very short. Now, ethical consideration in research are a set of principles that guide your research designs and practices. Science and researchers, must always adhere to certain code of conduct when collecting data from people or data from experiment. The goal of human research often include understanding of real life phenomena, studying effective treatment, investigating behavior, human behavior even, material behavior, and improving life in other way. When you decide to research and how you conduct the research involve key ethical consideration. Is very, very important. So you see, whatever I am discussing, just for a few minutes, Forget about the paper we publish. Forget about what we contribute. If it is not ethical, then what is the meaning of publishing 1,000 papers? It has got no value. So you see, honesty is something, or sincerity is something that exists in every human being. Even then, we try to differentiate one person from other. This is our habit. Because whatever I am producing with my honesty and sincerity, I'm not happy with that. I want something more. I want 1,000 papers. So you have to decide what is true. You see, when I was young, 25, 30 years age, people used to call me seminar bird because I used to go to different parts of the country, abroad, just to present papers, these, that. But my intention at that time was to visit different countries, different states. It was wrong. Or maybe, it happens to person of that age. But when slowly I realized, now I'm not going to deliver a lecture anywhere because I think that, that it is difficult for me to fly to Chennai and stay there for 3 days, neglecting my HIT works. No, it is not that important to me. If it is really that important, well, okay, I'll take that pain to go there. Now, this consideration were to protect the right of your research participation, enhance research validity, maintain scientific and academic integrity. Try to understand. If you copy something from somebody, I found that one vice chancellor lost his job. So losing a particular job, I don't know what is the effect on that person, but if your academic integrity is lost, everything gone. Everything gone. I don't think that this kind of attitude should be there in anybody's mind, or this kind of people should not be close to academics. The diameter of the academic circle may come down. Doesn't matter. Doesn't matter. Number of PhD will come down. Doesn't matter. But it really matters that if we are producing garbage, if we are producing dishonest people, it really matters. Now, this ethics is very, very important to all of us. Now, why do research ethics matters? Research ethics matters for scientific integrity, human rights, and dignity, and collaboration between science and society. I have already told you in a different language. These principles make sure that participation in the studies is voluntarily, informed, safe for research subjects. Suppose you are doing some kind of research which may affect a particular person. While conducting the research, he may suffer from some disease, maybe cancer. In that case, you have to be careful. You should not enter into those things without protecting yourself. You will balance your pursuing important research objectives with using ethical research methods and procedures. Whatever the example I've given you, this is the the sentence for that. It is always necessary to prevent permanent or excessive harm to participants, whether inherent or not. So you can easily understand it because this is all common sense. I am just remembering you. Just you know everything because you people are very good, not like us. We have spoiled our country. We have not done anything in last 40 years, but you people are doing very good work, and I am expecting that within another 50 years, India will be at the top. And you see, these are the things, lower credibility, all these things. So sometime if you again go through this YouTube, you will appreciate more research ideas available to society and all. Because we don't have time, I have got some more slides to show you. Now you see the type of research. It may be pure or applied research. Some research are there which are pure research. Applicable is not directly, immediately at that particular stage. Suppose you are working on matrix, algebra. You are working on tensor. Or you are working on a particular numerical method, which may not materialize at that particular moment, or may not be directly applied to a particular problem, which mathematics they are doing it. So this may be a pure research, but it has got indirect effect on applied research. That is the base. In our country, these people are not really appreciated to a great extent. Sometimes they are not getting job also. But those people like us who are engineers, without knowing anything, sometimes we get job. So sometimes people getting frustrated by doing pure research because applied research has got more return. But anyway, both are extremely important. Without pure research, how can you do applied research? Then exploratory and formative research, descriptive research, diagnostic study, evaluation studies, action research, experimental research, analytical study or statistical method, historical research, surveys, case study. So there are so many areas. Now my problem is that if I want to discuss all these things separately, then maybe the coordinator of this particular FDP will be extremely unhappy with me. So I'll not do that. So the feedback on language structure formatting, academic style, vague sentences should be avoided. Grammar should be correct. Style, consistency. So these are the things, if you follow some good journals and all, and if you have a minimum knowledge in English, I think it can be developed within a very short time. But don't avoid this. Don't avoid this. A paper writing means something I have written and submitted to somebody. No, this is unfair. You are not only disturbing him, you are producing some garbage. Now you see the pure. It is a study on search of knowledge. It is the study of finding solution to a problem. Just find the difference. You see, abstract algebra. Yes, it has got application. So that's why, pure and applied, I told you that there is a difference, but many people, they are concentrating in pure research. And those things, we just take it from them directly, and we are giving solution to it, and our pocket becomes full of silver coins, and their pocket is empty. Now, you see the purpose of pure and applied research. Pure research, it can contribute new facts. It can put theory to the rest. It may aid in conceptual clarification. It may integrate previously existing theories. Applied, it offers solution to many practical problems, like we are doing, to find the critical factors in a practical problems. Many critical factors are there. If we do research on that, yes, it will take, your contribution will be much more acceptable to others, to the industry. Now, exploratory or formative research. Exploratory research is the preliminary study of an unfamiliar problem about which the researcher has got little or no knowledge. So that kind of research we say exploratory research or formative research. Because why I'm telling you, because this kind of term, people are using it. And it is important for us to have knowledge about these nomenclatures. Because with one word, formative research or exploratory research, that person will be able to give you an idea that what exactly he wants. Without going into detail, if you have the correct idea of the nomenclature, the exploratory, formative, like that. Now, purpose, this kind of research, to generate new ideas, to increase the researcher's familiarity with the problem, this is exploratory research, to make a precise formulation of the problem, to gather information for clarifying concepts, to determine whether it is feasible to attempt the study. So these are the, purpose of exploratory research. Descriptive research. Descriptive study is a fact-finding investigation with adequate interpretation. It is the simplest type of research. It is designed to gather descriptive information and provide information for formulating more sophisticated study. Data are collected using observation, interview, mail questionnaire, because in many situations in management, you may be using interview as a tool or mail questionnaires as a tool. Purpose, what is the purpose of this kind of research? It can focus directly on theoretical point. It can highlight important methodology aspects of data collection and interpretation. It obtains in research may be useful for prediction about areas of social life outside in the boundary of research. Descriptive study are valuable in providing facts needed for planning of social action program. So every research has got some purpose, like diagnostic study. So like that, if I continue, then all those lists will come. So I'll not be able to do it because it is 4:45 and the coordinator will be already unhappy with me and I don't want to disturb him because he or she is the person who has given me the opportunity to speak before you. Now you see the purpose again, then again evaluation study, again the purpose, and action research, what is it is, and the purpose, and then experimental research and the purpose, and then analytical study and the purpose, then historical research and the purpose, survey research and the purpose, case study and the purpose, field research and the purpose. Research design processes. The selection of research topic problems, framing, research design, framing, sampling design, collection of data, data analysis, editing, coding, processing and preservation, writing research reports. Very important. Now, this characteristics of good research, again, there are many points, and every point, if I try to elaborate, I don't know, maybe another 2 hours will be required. So I'm skipping now. So only thing that you just see why it is required, and function of research design, right? So these are the functions. Then component of research design. These are the components: title of the investigation, purpose of the study, review of related literature, statement of the problem, scope of the investigation. These are the components. Objective of the study, variable, hypothesis, selection of samples, data collection, analysis of data. Type of research design, experimental or non-experimental. It may be quasi-experimental or fully experimental. Non-experimental design, I have given some, I have highlighted few things, but now it is 450. Hypothesis, what it is. It's another important aspect. Define, how to define it. Difference between your hypothesis and your problem. When is an hypothesis formulated? Purpose and function of an hypothesis. Characteristics of an hypothesis. Type of hypothesis. What are different types of hypothesis? Like this, casual, this working, null, this is the different. And everything is important. Everything is very, very important. Because you see, I told you in the beginning that throughout my life, whatever I have done with my students, just to make myself happy. I'm not doing for anybody. I am doing for myself. This is my food. My students are giving me that food. And I'm lucky to have a very, very good students at JU and other places, and also in our mini Jadavpur, HIT. And you see, these characteristics of good hypothesis, these are the things. If we discuss one after another, then you will be able to appreciate. Source of hypothesis, sampling, what is that, what exactly it is, basis of sampling theory. You have to be very careful about it. And sampling errors, What is that? Developing sampling plan, then defining population of interest, sampling frame, sampling methods, then types of sampling methods. It is simple random sampling. Just I'm showing you because time is almost over. This is one more thing I wanted to discuss. But anyway, now we don't have time. This is the research report should contain this. This outline means for a particular research. For a particular research, this was the outline. Just an example. Now, science is not a belief. It finds out the truth and helps us for innovations to make our world better. Thank you very much. Thank you very much. Especially the coordinator, because he or she allowed me to speak for around 120 minutes. Thank you very much. And in future, if the coordinator and other faculty members, if they allow me to speak about it, I'll be really grateful to them. I'll try to do justice to that. Today, you have seen that I could not do justice to it. Means at the later stage, I could not explain many things. Anyway, that happens sometime. Thank you very much.
Thank you, sir, for your very informative and detailed presentation. Uh, I'm sure, like everybody has, all the participants have benefited from this session. Sir, you have, through your presentation, you have not only given us the tips and details about the steps we should carry out in our research, but also you have discussed with us all the real life application problems and solutions. So it's a very wholesome, I must say. And thank you, sir. And not an issue that in the later part it was just a present slides only. We can continue in some other sessions also, sir. Thank you. And now I would like to pass on to Dr. Atri Bandopadhyay for the question answer session.
Thank you, sir, and thank you, ma'am. Sir, the one, as we all know, that you are a pioneer of this field, especially in research field. So means as well as it's expected from you that you will give an immensely knowledgeable presentation. Also, it was so lucid and importance of that subject of research methodology to us scholars and researchers. It was so beautifully portrayed, and literally very much thank you for your wonderful presentation for that, sir. And for the question answer session, if anyone from the in-house have any questions, please go on. So I don't think anyone have any question. And sir, for the comment section, every participants have commented so much, means wonderful words for the session. Everyone is so much satisfied that everyone has asked you for, means if the material can be provided to them also. It was so helpful. So means it's already full self-contented. So thank you for this wonderful session, and hope to gain knowledge from your sessions again and again. Thank you, sir. Now I would like to welcome Dr. Payal Choudhury for our valedictory session. I am handing over it to Payal ma'am. Thank you.
Thank you so much, madam. I'll be starting the valedictory session, and I would like to now extend my vote of thanks. I would like to acknowledge our principal sir and dean sir to take out their valuable time and address this program. We are also very grateful to our registrar sir and other administrative staff for supporting us with all the facilities we required. I would like to express our gratitude to our head of the department, Professor Shashank Shekhar Hota sir, for helping us with all the approvals and other guidance required for this session. I am extremely obliged to our emeritus professor, Professor Somnath Ghosh, for guiding us in conducting such wonderful sessions, wherein we are able to communicate with the world outside, and also for inviting prominent expert speakers for our sessions. I would also extend my earnest appreciation to Anupam De sir, who is technically supporting us with this 5-day online faculty development course. We would be indebted to our college, Haldia Institute of Technology, for providing us with all the facilities to march towards value addition and continuous improvement. We are hence immensely grateful to our prominent speakers, Professor Somnath Ghosh, Dr. Jyoti Dule, Professor Anjali Pal, Professor Partho Ghosh, Professor Amiyo Kumar Shamanto, Professor Damodar Maiti, Professor Amarnath Reddy, and Dr. Supriya Roy to illuminate and educate us with their expertise and distinguished lecture sessions throughout the week. I would hence want to appreciate our coordinators, Dr. Bijali Mandal, Mrs. Dipti Yelanki, and Dr. Atrey Bandhapadhyay for their ethics and diligence in managing the program in and out. I would also like to express my gratefulness towards Mrs. Shomi Rajbamshi, Mr. Amit Goldar, Mr. Satyabroto Patro, Mr. Ajit Paria, and Mr. Shobhik Dash, who have been functional meticulously round the clock for this initiative to achieve success. Last but not the least, I wholeheartedly appreciate the cooperation and exhilaration deliberated by all our faculty members. However, please hold back. There is a last announcement coming up. A Google form for e-certificate will be provided in the group shortly, which should be submitted duly. Upon submission of feedback form, e-certificate will be mailed to the respective participants. Please note that the process is mandatory. I would now thank all the participants for attending the program. Thank you so much. The session is dismissed now.
Before the session is dismissed, ma'am, I would like to extend my heartfelt gratefulness and appreciation towards Dr. Payal Choudhury for taking this valedictory session. Thank you, ma'am.
Thank you, Payal. Thank you very much.
Thank you, sir.
Excellent. And the others, our faculty members, they are really excellent. My last 2-3 years in this world will be better, I feel.
Thank you, sir. Thank you so much for being with us and also taking all such initiatives in our department. Thank you so much.
Thank you very much.
Thank you, sir.
The session is now dismissed.
Thank
Thank you, sir.